what I remember from talking about that.
Yeah.
I didn't start the recording. Can you give a summary of what's happened? I'm sorry I'm late.
Yeah, no problem. We're sort of discussing at a high level the differences between the algorithms, consensus algorithms we've discussed so far. So obviously we've talked a bunch about CBC Casper, some about Casanova, some about Hashgraph, and so we were sort of comparing properties of those.
Thanks.
One thing I remembered was that Hashgraph claimed to have a total ordering over transactions, right? And that's definitely something that Casper did not claim or find desirable.
Mm-hmm.
Mm.
Yeah.
But when you say find desirable, but in a round robin, sorry, in a round robin settings, when messages, when you have rounds,
Mm-hmm.
this implies some kind of ordering.
Mm. So round robin, what does round robin mean again? Is that where, like, I know in Hashgraph there were the rounds where, like, if we're drawing this, DAG growing up and up, like we draw a horizontal line every once in a while, and we say, like, this set of messages in this region counts as one round, and then this is like the next round up here. That's different than what Vitalik was describing, though, where, like, Alice gets to make a block in this window and then Bob makes a block in this window, right? Or are those related?
That's separate, because one has a leader each round. Round robin is a leader selection algorithm, and Hashgraph has no leader necessarily. It just has witnesses.
But not round robin in that sense. Vlad was explaining round robin is in a sense of optimization. So if we have some kind of gossip protocol or something like that, the most efficient way would be that we know what is the order of gossiping, so that each message finalizes one block. This is like ideal, right? So you publish a new block, and automatically some other block in the past is finalized, and then new block is published, then some other block is finalized.
So that makes sense, Tomislav. That's when I see Vlad showing these figures sometimes, and I'm just putting it together where it's it kind of looks like the Casper diagrams. Yeah, it just has the diagonals going up, right?
Yeah. And he was saying, like, this is the optimal way. But this is also like an assumption similar in Casanova. When you have assumption that everyone is playing fair and doesn't cheat and like that. You must have some assumption about that, because you are expecting each validator to produce something in regular interval.
Yeah.
So in that sense, for me, it's difficult to
and there's that synchrony assumption there too.
Yeah. And then in Hashgraph and Casanova, everything is like mixed up. It's difficult to understand what is the algorithm, what is the optimization.
Yeah, so with the round robin thing, I almost think there's like two different ways to set it up. So I get what you're saying, Tomislav, right? Like, if we go in order, we get that super nice diagonals graph and with all the properties you just described. So, like, one way is to say, like, this is the protocol, this is what we must do, and then there's some incentive structure to do that. Like, if you go out a turn or miss a turn, you get punished or something like that.
Yeah.
And then another way would just be like, look, guys, we all know this is how it works best. Let's just try to stick with that. And if someone misses a message or goes out of turn, then, like, we're suboptimal, but we're still going to try to stick to the optimal thing, like on a best effort basis or something like that.
Yeah, exactly.
Mm-hmm.
So in that sense, they're talking about the same thing in Casanova, or not?
I don't know. I don't remember. I sort of thought on Casanova it was still like the free for all thing, right? Like there's a DAG, there's a bunch of tips. When you build a transaction, you don't even select the best tip. You just build on all of them, and then, if it turns out you have a double spend or a conflicting transaction in the future, it becomes clear to everyone, and we just, implicitly vote and strike one out.
But in more higher level, you are agreeing of what Isaac said. You're agreeing on some synchronization.
Oh, is that true?
Yeah,
how are you thinking?
How do you calculate messages, and I don't think this is like a more like a general thing. You can have different algorithms to calculate the message, but you must agree that you will definitely publish in this exactly after other validator, and
Oh, I didn't remember that. What did other people how did other people remember Casanova?
I mean, in that sense,
Yeah, I would. Yeah, no, I was just gonna say I remember trying to even talked about how they resolve the double spends.
Isaac, can you repeat the beginning of your sentence? Something was breaking up, at least for me.
Oh, yeah, sorry. Yeah, my connection's not very good right now, unfortunately. Yeah, I was saying that.
Oh no.
Casanova, I think if mechanism that we use to resolve double spends. Are you guys hearing me?
You missed the same part as last time.
Oh, great. Double spends. How do they resolve double spends in Casanova? This is frustrating.
Yeah, it's okay. You're doing great.
Yeah.
Oh.
Did you hear it that time? Damn it. How do we resolve double
censoring you, dude?
I'll just type it in.
Okay.
I heard it.
Funny. We can hear everything else.
Resolve double spend?
Yeah, exactly.
Yeah.
We need a recap on the Casanova paper.
Yeah, maybe we should grab it out. I don't know. Ooh, I don't have it on this computer, but I bet it's online.
I think it's in that Google
side
Drive. Yeah.
Really, side note, I sent. I was curious the other night about how Ripple's consensus works. So I kind of sent that in the Discord for future, I guess, leisurely reads if you guys want.
Yeah. All right. I've got the Casanova paper here. Let's see what kind of words we can find. Ooh, no control F. There we go. So, okay, so this is the optimistic part. The majority of users don't double spend. And so I think the deal there is like all transactions are welcome into the DAG immediately, no questions asked. And then only if we see a conflict in hindsight do we deal with it. Okay, so I think that's all they're talking about here.
So I'm curious to know, so just like reflecting back on that statement in terms of no user double spends, like it's technically true, but is that like just like their lazy way of saying, all right, we're going to take a risk on, let's just say 70% of the users, let's just say 80% of the users aren't going to double spend, but we're just going to create just enough security or levels to where if the other 30% or 20% wanted to do it, we'll just fix it?
I
because
think
most consensus protocols have it automatic, like, that's the first thing they look for. But here it's just weird that they just like, you know what, screw it. We're just gonna, go under this assumption before we build it. It's just like a weird way of looking at it and how they went about developing it.
Yeah, honestly, I think what they're thinking was basically it's a trade-off no matter what. So like whatever level of double spend monitoring you have, it's going to be a trade-off with performance. And so they just went with, let's get the most performance we possibly can. And if we detect a double spend, then we'll have some like external thing to resolve them.
Yeah, it was almost like, so I was kind of thinking about this. I was watching a South Park about airport lines and how it's annoying to go through security. And the current airport security scheme is kind of like the Bitcoin scheme, right? Like you make sure in advance that every single person no matter how likely they are to be totally innocent, doesn't have any like weapons or anything on them. Because in reality, like if someone sneaks a weapon in, there's no like undoing that, right? Like they cause damage and that's it. But I
Guilty
think
till proven innocent.
what was that?
Guilty till proven innocent.
Yeah, exactly. And I took the idea here as like, yeah, those lines take forever, and it would be great if we didn't have to do that for everybody. So let's let everybody through, and then when someone has a weapon or like, you know, does a double spend, in blockchain context, we have the possibility to go back. This is a little bit weird because it seems like maybe it questions immutability, but it's maybe like mutating something that's not finalized yet. But like, you know, we've got that transaction that went in there as a double spend. We can go back and just cross that one out without having to hold up everybody else at the line there.
Mm-hmm.
I don't know if that's a good analogy or not, but
That's really how it works, though. So you can go back and mutate the chain.
well, it's like I think they use the word line item in here. Maybe Derek just used that, but he was basically saying like once you notice a conflict, so like a double spend, two transactions that conflict, they're both in the DAG, right? Like in Bitcoin, the rule would have been choose a chain such that only one of those two things is in the final chain, right? Like it's unacceptable to have a final chain that has conflicting transactions. And the Casanova approach is like, it's fine, you know, like, yeah, one way is to never write that thing down in the chain in the first place. Another way is to just have it still there in the chain. Like, yeah, some people thought this might be history, but now we see that in fact it conflicted and the other one was valid. And so like in Bitcoin, where you would have had to fork to get rid of that one bad transaction with like a ton of collateral damage, a ton of other totally valid, innocent transactions also getting forked off. All of those get to stay in the DAG here, and we're only like crossing out that one bad one.
Interesting. Hashgraph is kind of like that too, where if you fork in history, that's just kept within the hashgraph. It's also a DAG. And the difference is that then from there on out, if you can prove that a member forked, then that member is just no longer considered for any transaction. Which I guess is the punishment.
Yeah. How does that, is that Sybil resistant though? Like, can I just spin up another key pair somewhere and?
Right. Like, yeah, I don't know. It seems like you could.
Yeah.
I mean, but every time you would be losing some amount of money in that wallet. So.
Oh yeah, I see what you're saying. So it's not free.
Yeah.
I wondered if we were going to get more about double spends, but I don't know. I don't know if we are.
But how finalization works in Casanova or Hashgraph? I mean, you sending.
Yeah, that's a great question.
You're creating new blocks with transactions that you want to make consensus of. Or for example, we can go on the beginning and say if we have centralized database and it is the only one, so our transaction will be finalized immediately, right? This is like you will get the most performance because each block is automatically finalized. But when we extend this to the centralized system, we don't have this property anymore. So you must have more blocks that you confirm that is final. So what I want to understand, if we have this situation like Vlad is explaining with round robin, how can this be better in Casanova or Hashgraph? Because you have really you just create a new block and you have another block finalized. I mean, is there a way to be more performant?
Well, I think one counterpoint to that, Tomislav, is that there's the issue that Casper doesn't have a liveness proof. So even if it does have that performance benefit, one strength of Casanova over Casper is that it has the liveness proof. And then another thing was like if.
Can you define liveness on this general level, because it is always in contrast to safety.
Yeah, so here's what I've understood Leibniz to be, but I'm not confident that this is like the definition or anything. But I always thought it was
I can
something.
read the definition right
Oh,
now.
please do. Yeah, that sounds great.
This is from the Casanova paper. Live, if the protocol guarantees that for all I and I, a correct validator V has not seen a DAG D such that they can decide on such that their decision on D is null, or that validator V eventually sees a DAG D such that their decision on D is something. Maybe your definition is a little less cryptic.
Is this where you were finding that definition? 5.5?
2.5.
Oh, gotcha.
2.4.2.
Oh, here we go. Okay. Oh, there we go. Okay, this one. Yeah. If the protocol guarantees that, so I think after that, if the protocol guarantees that, and then this is just going to be like some good thing that we all agree we want to happen, right? So we can try to parse that, but I think liveness generally means like whatever good thing you're trying to achieve, the protocol guarantees that eventually that good thing will happen. And so I think this is going to be something like, we agree that a transaction actually happened. So
yeah, my understanding, it's like that consensus will eventually hold.
Yeah, but if you don't have a time boundary, you cannot define, you cannot prove liveness. This is like a known thing. So if you have assumption about time, you can prove liveness, but this is not a part of the Casper. This is part of the implementation.
Well, Leibniz doesn't really say anything about time. It just says that the algorithm will eventually halt or complete. There's a proof that it'll eventually happen. It doesn't say anything about when.
Oh yeah, that actually sounds like the behavioral type we were talking about at the beginning, right? Like this string of not being live transactions is finite and terminated with now this good thing happened or something. So how did liveness work in Hashgraph?
It's a good question. I don't know if they really mentioned it. Do you have any good resources, Joshi, on behavioral types?
What was that?
Do you have any good resources on behavioral types?
I totally do. Dan Connolly posted one the other day he posted a Coursera that I've been following. I have loved it so far. I guess it's mostly about Hennessy-Milner logic and extending it into the modal mu calculus, but it sure seems like behavioral types. Let me see if I can grab it.
Yeah, I got to check that out.
Yeah, I can grab the link, but it might take up to a minute to find it.
We said it's a Coursera course, right?
Yeah, totally.
Cool.
For some reason, I'm not logged into Coursera. I guess I'll post it on Discord soon.
Awesome.
But yeah. Okay. Well, maybe we should make a plan for what to cover next week and what we should all be prepared with. I think that's gonna be. We were doing that for a while at the beginning.
Mm-hmm.
So I guess for me, I would be most interested into sort of finishing our understanding of LMD, bitwise LMD Ghost or Casanova. We could maybe come up with a reading assignment or an exercise or something.
Yeah, I'd like to finish our discussion of LMD Ghost.
Yeah.
But I do have one quick question though in regards to this. How would it handle, like for Casanova? I'm not sure if we already talked about it. Where if there was so we already just briefly talk about double spending, but how would it handle like a faulty transaction during the actual consensus program? Does it just automatically drop it and then moves on, or is it automatically discarded or even before it gets to the node itself, before it's verified?
Faulty, you mean faulty transaction, like just invalid? Like I spent more money than I have, or it doesn't have a valid signature?
Yeah, correct. Or possibly double. Well, we already went over double spending, but yeah, essentially that.
Yeah. So I think basically, if a transaction ends up in the DAG, validators would see it and not build it. Well, no, that doesn't seem right. How does that work?
That's the reason why I asked when I was reading the. Oh, sorry.
Oh no, go for it.
Oh, the reason why I asked was when I was reading that Ripple paper, they were saying as part of their consensus, they gather all the transactions up, and then they need like a certain amount of votes on it. But the transactions that didn't get the amount of votes because they believe of bad behavior or like just a faulty transaction, it gets dropped and has to go down to the consensus round, and then the all verified transaction goes into the next form of consensus with the other validators. So it's like a filtered, layered process.
Yeah.
Are you saying that they find the transactions inside the block that is invalid, and they just use the other ones that are valid and create a new block?
Correct.
Yeah.
And that just gives you a performance speed up.
Let's see. Successful agreements. I'm not really sure, like, how would it be performance, because I didn't really talk about that, because I have to just go into how they prevent forking. But yeah, I can only imagine though that would be for more security than performance.
Yeah, I mean, I could just imagine that you could continue moving on with consensus while you're, I guess, worrying about punishments or slashing and like a separate chain, if that's how that works.
Mm-hmm. But then again, I wonder, like for speed, since they did say that they gather all the transactions and put it in the block, I wonder if they instead of just like having like a set amount of transactions where they just like, for instance, for one day, we're just going to take every single transaction, gather all up, send it to each other, vote on which ones are good, which ones are bad, and then pass it. Because then you pretty much have like a infinite, or not almost like an infinite amount of transactions. But I don't know. I got to think this one through before I speak anymore. Sorry. Or just keep reading through the paper, that is.
But you're thinking of how if we have optimal performance, how this looks like. So right.
Yeah, I mean, I sent the paper in the Discord, so if you guys wanted to check it out, you can. Because there's like some parts that are kind of fuzzy, but like down the road, we can like kind of prep for it and just like go over it once we're done with the consensus that we're working on now.
Mm-hmm.
So yeah.
Yeah, Ripple's been out so long. It would probably be considered like version 2 of blockchain consensus algorithms.
So is Ripple the one where if you want to do a transaction, you actually have to validate a couple of transactions?
No, that's IOTA, I think.
IOTA, okay.
That's a pretty interesting idea.
It is. That's really cool. Yeah.
So how does that work? If I want to, is it a cryptocurrency or smart contracts?
Yeah, exactly. I forget exactly, but it's basically just you have to verify 2 other ones and their links to other ones. And then you somehow prove that verification, and that becomes part of your new transaction. And then it's like each transaction is not quite, it has like a degree of validity, and as more new transactions verify that one, then you become more valid and carry more weight.
Mhm.
That concept seems familiar. Like we've seen, more validators building on top of blocks, adding their weight to it, getting it closer to finality.
It's true.
Yeah, I dig the idea of having to contribute a little bit before you get to make your own transaction.
Right, it like reverses the process.
So, what would happen if someone just made a BS account with maybe like one token in it, voted on a bad or double spending trend or just like a bad transaction? Like, what would then like happen? Would it say, "Oh, we're just going to take your one token," but then again, someone could just make a new wallet and just like keep doing it again and again and again. But then it'd be counterproductive the more I think about it because you're losing money. So that kind of works.
Yeah, that's right. IOTA, I think, is built for IoT applications, which is why they reverse the responsibility to the transaction writer instead of having some central or some more powerful system that's able to verify blocks. Like most systems are heterogeneous, and there's the validators and the clients. This one is more like each client just does a tiny bit of work, and therefore all the clients can be, little embedded processors.
My impression, I recently reread the Bitcoin white paper, and my impression was that like at the time, Satoshi might have been expecting like everyone that's using Bitcoin to transact will also be mining. And, in hindsight, that turned out not to even be close to true. But like maybe with that incentive, like with IOTA, it sounds like maybe that is what would happen, right? Because you have to do a little bit of mining to transact. Yeah. I'm pretty interested in that.
Is it that Hashgraph also works like that? All the participants are really validators.
Oh, I guess I just assumed those validators were collecting transactions from other non-validators. I don't really know though.
I understand that they're all the same. They're all special validators. So.
Which chain?
I'm not sure.
I mean, I think you could be a validator in Hashgraph that only creates events and sends them out onto the network, and you wouldn't have to worry about the ordering. You could let the other members validate the ordering for you. So there's no real responsibility to participate.
Oh, like a read only.
Yeah, or write only. Like,
right.
Yeah, you could just write.
Because Jay, you're saying you can like, so like if we're making a Hashgraph network here and we're all validators, but I'm mostly just interested in doing my own transactions and only interested in the network for like some sort of record or history, I guess, then I can just like make my own events and send them out without really otherwise like taking calls from other validators and stuff.
Yeah, exactly. Because you don't care about the ordering, and only people that care about the ordering, would have to be concerned. And there's a proof that it'll be consistent, so you know that your transactions will eventually be validated.
But if you do that, you don't have the whole database, right? If you say you're right only, so how can you verify that your transaction is accepted or finalized? Or you must be connected to to other full node who knows that. I mean, you must put trust in someone else.
Yeah, you must put trust in someone else, but because the graph is eventually consistent, if you wait long enough and then query that node again, then you could know if your transaction was validated.
But it then says you're just connected to one node.
Yeah, as long as that node is not behaving
specifically lying to you.
Yeah.
You can use my node.
I mean, all nodes are validators. So.
Yeah.
You can send your transaction to one node and read from other one.
Yeah.
Just to be sure.
Yeah.
Hey Jay, can you send I'm on the IOTA site now trying to find the consensus or information on their consensus. Can you send it to me if you have their white paper on that or their academic paper?
Yeah. Let me see.
Thank you.
Just drop it in Discord if you have it. I wouldn't mind skimming it either.
Yeah.
All right. Well, guys, I'm almost inclined to say we should switch over into the Roland K-framework stuff a little early today. What are
There's one
people's
thing
thoughts?
that's been on my mind that I'd like to run by you guys. Which I think I may probably mentioned it before, but I'm thinking about in nature, the blockchains are partially ordered, and has any is there anything that uses partial ordering where first you have block 1, you have block 2, 3, or 4. You don't care what order. I mean, it's a little bit like processes in PAR. You don't care what order they're in. And it would seem that you wouldn't be making unnecessary decisions if you use the partial ordering. How does that fit in? What are the thoughts on that?
Yeah.
Let's say maybe one lazy evaluation scenario would be quantum mechanics, where you don't have to order things necessarily or even evaluate them until you observe them.
I think Casper does only enforce and only come to consensus over a partial ordering of the transactions. Isn't that why like Greg was so into it, and like Casper Labs is still talking about consensus level concurrency?
Yeah, that was what sometimes I think, and sometimes I guess that's where there's some confusion. So
yeah,
thank you for bringing that up again. In some way, it handles that.
Oh, I think Casper does. Yeah, because like with Casper, you can have like a block, and then it has 2 children that go off of it, and then a fourth. So now we've got 1, 2, 3, and then the 4th block comes back together and builds off of both of these. So we have partial ordering now, right? This bottom one was before the right one, and before the left one, and before the top one. But we don't know, like, of those 2 sibling ones next to each other, we don't know which one came first, and we don't care which one came first. Does that sound right?
Mm-hmm. Yeah, just as long as they came after the first and before the last, then.
Right.
Mm-hmm.
Yeah.
Okay, that sets my mind at ease.
Yeah, I think Casper gets you what you're looking for there, Jim. And also, like, Casanova is still trippy to me, but I'm thinking of Casanova in this way where, like, eventually we get an ordering. No, I don't even know if that's true. I don't want to say things I don't know about. I've been thinking about this idea where, like, anytime that a partial ordering is sufficient, it doesn't hurt to have a total ordering. If it just so happens that we know a total ordering, that's not, like, worse. And so I'm wondering about these situations where, like, maybe as the DAG is being built, initially we only have a partial ordering, and we can say, like, oh, well, that's all we care about. It comes after this one, and it comes before this one. And so we, like, good, that's all we care about, move on and keep working. But then, like, as the DAG continues to grow, eventually it becomes clear that, like, there actually is the total ordering, even if we don't care in every situation. Something made me think of that recently on these calls, but I forget what.
Well,
Probably.
my worry is, when you decentralize, you have perspective. And in the natural system, you have ordering based on perspective. And in essence, when we go for global consensus, we're taking a preferred God's eye view of a particular ordering, so to speak.
Yeah, I have also an analogy for some chemical reaction. Ordering of molecules that you put in a mixture is not an element, but the ordering of a chemical reaction will be very, very ordered, right? You mean, you must put exact amount of these two chemicals to start reaction, and then you can put maybe some other chemical and start other reaction. So in that sense, you have ordering of reactions, but ordering of molecules are not important. In that sense, I'm thinking about the blocks and transactions. You can have partial ordering of a block because they're not atomic. But if you have one transaction in a block that are dependent one on another, you must have total ordering. But because we have multiple transactions in one block, we can say we don't care about total ordering of blocks.
Wait a second. You're saying, I love the chemical analogy. You're saying you think if we were to get rid of this transaction aggregating thing, and instead of putting multiple transactions in a block, we're just saying like there's no distinction, every block is one transaction and every transaction is one block, then in that case total ordering is necessary?
Yeah, because if transactions are related.
Right.
Because we must know which transaction will become first, and
But so imagine that
we don't really have transactions. We have state of the virtual machine, right?
Yeah.
So
if we run only one program, we must know the ordering.
Yeah.
If we have sequential program, we must know the ordering, right?
So what if imagine you get like some payment that's like 10 tokens, and then you pay 3 of those tokens to me, and then you pay 3 of those tokens to Jay, and then Jay and I each pay our 3 tokens to Jeremy, so he has 6 now. I don't think we need to know whether you paid me first or Jay first in that case.
I don't think this is important, but you must know if I have any money to.
We need to know that you got paid before you paid me, and we need to know that you got paid before you paid Jay, definitely.
Yeah, and you must know if I made the first transaction, can I have the money for the second?
Yeah.
Yeah, but it wouldn't matter which one came first. Like a subtyping problem, like it could either be me or Joshi.
But first transaction can be, but this both transaction can be more than that I have. So after first transaction, maybe I don't have money for the second.
Well, you got to check that each transaction is valid, but the order doesn't matter.
Yeah.
So I think so. In the case where he doesn't have enough money to pay us both, then the order does matter.
Yeah, sure.
But if you have enough to pay us both, then I think the order doesn't matter. Right?
Yeah. In that case, it doesn't matter.
Yeah.
And it's maybe questionable whether the order does matter. I know a lot of algorithms would kind of just choose one based on which one disseminated to the gossip first. So, I mean, I don't know if order is necessarily what matters there as much as just reaching consensus on one of them.
Yeah, you're right. Yeah, I was basically using order to mean that. It's funny how like words can shift meaning where like I don't even really care which one he sent first. It's just like whichever one the network accepted first.
Yeah.
So by that definition, I wonder how would that work, for instance, like let's just take Ethereum, for example, where if I would have sent Joshi 3 tokens, and then by that definition, assuming that it's already been mined, so where I'm trying to get at. So theoretically, Joshi already has it, but in the actual network, it's still being mined. So assuming that Joshi tries to send a token while it's being mined, that won't happen, which means I totally did not formulate this question right. Give me a second. Sorry.
I think there's something there, Jeremy, right? Like you want to pay me some tokens, so you send the transaction. You just did it. It hasn't made it all the way around the network yet, so most people think you still have the tokens. So like if I try to spend them now, my transaction won't get accepted until after yours has, I guess. Or on an individual validator basis, like no one will include mine until they've included yours.
Yeah, exactly. I had this issue for a long time too. That's it, because if someone else tries to spend their transaction because they know that you paid them and they're trying to spend that money, then and they send that out and somebody else hasn't seen the first transaction, then on the Bitcoin network, that's just considered an invalid transaction because you're spending money you don't have, so they ignore it.
But then there's nothing to prevent me from sending that out again, or a node that's, you know, maybe trying to be a little smarter from like holding on to that and checking again in an hour or something.
Yeah, exactly. But also, I was just going to say about Hashgraph, like, yeah, you're right about total ordering, like, being not a bad property if you just happen to get it. But I guess one of the issues with it is as, like, we scale transactions to really high numbers, I think Hashgraph becomes unviable as, like, a world consensus algorithm because you would have so many validators that all of a sudden you would expect everybody to be hosting these giant files and doing these giant search algorithms, you know, through hundreds of thousands of members each round. So, yeah, I still think that total ordering is not as scalable, I guess, as partial ordering.
Yeah. Jay, do you know that? Oh, sorry. Go ahead. Go ahead.
No, I was just want to ask total ordering of like the whole graph, or I was thinking that total ordering is just in one consensus block, or one gossip. I'm not sure how to say. One group of gossiping messages. They're not making the total ordering of the whole graph, right?
They do in effect, but they just do it round by round. So each round is ordered, and then each transaction in a round is ordered.
But all of this ordering is also part of the bigger graph, which is not ordered, or
no, it's all ordered. Yeah.
There's relative ordering from each participant's point of view, which in nature it's expected, and I would expect your ordering to be not the same as mine based on spatial qualities, which we don't really have yet. But I would like to see what Joshi had in mind for the ROLAG.
I just had in mind the stuff we do every week where we look at the, you know, Isaac's K-framework implementation and Tomislav's Haskell, and I started one in JavaScript last night.
Oh, nice.
Oh, cool.
I decided it would be better for me to program in a language that I know how to program.
Cool.
Are you going to continue with the Haskell
I hope so, but
implementation?
it's just super hard to work on a hard problem and learn a language at, you know, when those things are.
I know exactly what you're talking
Yeah,
about.
that's right.
Yeah. And I think the documentation for Haskell might be a little better than for K-framework.
Totally. Yeah. All right.
It's a smaller jump to Scala.
From what?
Java.
Oh, from Java. Oh, okay. Yeah, maybe you should try Scala.
Another language I don't know.
Yeah, right.
Yeah, and Scala has like 20 years of just complex features with it too. Like I was learning about generic types. They don't just have generic types, they have plus generic types and minus generic types, and both of them like inherit different roots in the trees. And I don't know, Scala is a complex, like it's a fantastic language, but there's just so much to it.
Yeah.
Yeah.
All right.
I quickly tried to search for that Hennessy Milner logic course on Coursera and got a hit on functional programming and Scala specialization. So maybe.
Oh, that's a good course
maybe
too.
that's worth checking out.
There's a great video. Learn Scala in 30 minutes. Java programmers or something.
That doesn't sound real.
Well,
I don't think I can learn anything in 30 minutes.
Well, you know, it takes you as far as being able to do what you do in Java in Scala. Plus,
That's
you learn about
pretty
some
far.
features.
Mm-hmm.
You get some new freedom.
Hey, Joshy, that sounds like a good place to start, man.
Yeah, maybe I'll watch it. Is it on YouTube, Jim?
Yeah, I'll see if I can find it.
Oh yeah, cool. Hey guys, I'm gonna jump at 11. There's a Archain community meeting going on that I wanted to attend. I'm hoping to be back if anyone's still talking about K framework, Erlang, Haskell stuff.
Cool.
Yeah, so next week we'll continue with the LMD ghost calculations and what else? Did we want to continue discussing Hashgraph and or Casanova? It sounds like
Yeah, I'm into all those things for sure.
Okay, cool. It sounds like maybe IOTA as well, maybe Ripple. We should come up with a total ordering of those things and then cover them in that order.
Yeah. Yeah. One thing we did when we first started this that I think worked really well was, decided what we were going to cover in advance and what everybody should read and sort of have prepared on their own.
Yeah. And I guess we can maybe be better about like, having one person say like, okay, I'll lead the discussion this week. And then there's always like a different, person. So it's not constantly.
Yeah, that was really well last time when Dor was here. Yeah, that was a really good because it helps me get better when I was trying to lead it. And yeah.
Right. Yeah, right. Because being the leader presents its own challenges. So you definitely learn and grow a lot from doing that. So yeah, cool.
All right.
Maybe we can outline that this week in Discord, like who's going to take what week, since we just started March. So yeah, everyone just agrees on a week and just prepares for their.
Yeah, and like specifically, if you already have knowledge about something, like it seems like Jay knows a lot about Hashgraph, like that would be a super easy thing for him to lead.
Yeah, I only learned about it after we first talked about it, though. So I mean.
Yeah, cool.
Yeah, if we like decide a new paper like Casanova, I'm also still interested in Grandpa if we want to eventually cover that one.
I'm interested in Grandpa too. Yeah.
Okay. Yeah, I would love to talk about how finality is reached in Casanova. I don't think that's something we've discussed or.
Okay. Yeah. Do you guys want to do some Casanova next week? Should we plan on that?
I would be down for that. Yeah.
I could commit to reading. I've read at least half the paper. I could commit to finishing it next week.
Oh, great. Okay.
Nice.
Yeah, I should also probably commit to reading some of that and help you lead that one.
Yeah. Okay. All right. Cool. So let's make our rough plan for next week, Casanova, and we'll come up with a more definite plan in the next day or so.
Yeah. Cool.
Good hang, everybody.
Good.
Yeah.
Okay. I'm gonna jump out. Hopefully, I'll see you guys soon.
Cool.
All right.
See you, Joshy.
See you, Joshy.
Bye, everyone.
Out of curiosity, have anyone worked in Go?
I have.
Sweet. I've been trying to set up my Go path for this directory. I'm redoing some developer documentation. I'm going through the notes. I'm like, all right, so I already see where I need to set the Go path. I'm trying to figure out, do I just put it in the source folder, or could I just point the Go path to any directory? I'm on a Mac, by the way. Jeremy /documents / whatever.
So I mean, I think there's a good tutorial on this, but you usually want to set your Go path to some root file where I can find all of your projects in there. But you don't have to put it on the source. It'll find that file.
Gotcha. All right, let me just try that and see if that works.
Yeah, let me see if I can find that resource for you.
So do people want to talk about anything else now? Can show you some stuff I've been working on in K-Framework if you're interested.
Yeah, I am definitely.
Oh, okay, cool. So yeah, I got so I think I have something that's pretty close to behavioral type. So I was working on well, actually, let me just show you one really easy thing, and then I'll show you the behavioral type stuff that I had started working on.
So, real quick question.
Yeah.
Obviously, since I'm not at the same level you guys, like, can you just briefly describe like a behavioral type?
Yeah, I would love that too.
Yeah, so behavioral type. So in rolling we have structural types and behavioral types, and structural types are basically exactly what they sound like. They're very much in one-to-one correspondence with like the actual syntax that you're using.
Mm-hmm.
So you know, like a structural type, for example, I can show you what my structural types are doing. Let's see, that's the behavioral type one. This is something else. But essentially the structural type is going to tell me something about the actual syntax, and then the behavioral type will tell me something about, you know, what this term is actually going to do, like what reductions can result from the particular term that I started with. So I'll show you an example of the structural type first. So, okay. So I always get a small amount of anxiety when I try to compile my K definitions, because you just never know if they're going to work or not. I don't know if you guys
Isaac, can
still
we
get
say
that. Yeah.
Our current languages like Java or C# are like they have structural types only.
Okay, Java and C# have structural types only.
Because you just you can check like a static definition of language, but not dynamic, right?
Okay, I mean that sounds right. I don't know a whole lot about those. Let's see, what was I going to show you guys? Oh yeah, just some structural type, right? So let me let's see, maybe just do like an integer and see what happens. Yeah, so basically, I mean, I'm putting in the process that is the integer 12, right? And basically the structural type for that is very simple, because this is like a ground term, and all it's going to do is tell me that it's an integer and that integer has a value of 12. That's literally it, right? Something more complicated, like maybe there's something more interesting going on. Let's say, and we can look at the actual code for this one. But so, for example, dang it, I changed some syntax recently. You know what? Let's try another one. How about send? Yeah, really, I wanted to get some of this stuff together, so I had like very specific examples to go through. Because like at this point, I mean, I've made so many of these things. Okay. That I don't really remember a whole lot of like what's in each one specifically just by looking at the name anymore. But God dang it, I'm getting syntax errors for all of these. Oh, you know what? I know what the problem is. So I recently, so I've had this design choice to make, which is basically like, do I care more about having names, variables for names, or variables for processes? And so at first I was using variables for names, and I've recently gone back to using variables for processes. And so that's why I'm getting these syntax errors. Yeah, it's going to happen on all of them. Dang it.
So what made you decide to swap it to the other way?
Yeah, so basically what made me decide to change from name variables to process variables is I have kind of like two implementations that I'm working on right now. One of them is now name variables, and one of them is now process variables. The one that I changed to process variables, the reason I changed it to process variables is because when it comes to collection patterns, so if I have like a list that I want to match, there will be some process variable in that list that'll then, there will be some binding to that process variable to like fill in the rest of the list essentially. And so I thought that was an important enough feature that I wanted to be able to implement that exactly the way it's supposed to be. So now I'm trying to like backtrack from that point, and clearly I haven't gone through all of these examples to fix the syntax. So there's
but
just
what you want to show us, for example, this int. Int type. This
right.
is really like if you write in Java type int, like a number 12 has type int.
Right. Exactly.
Like,
exactly.
Exactly. The syntax tells you, this is the type, this is the value.
Right, exactly, and that's literally all it does, and it specifically tells me it's a leaf, and what the leaf means is just that if you were to draw like a binary tree that corresponds to this thing, leaf would be like the top node in that binary tree, and then two branches would come down. One would say int, one would say 12, basically. And so that's all this structural type is telling me. So there's not a whole lot of structure, within this number 12, as you would probably assume. Let me quickly fix like this com one, for example, just so we can actually see what the structural type for that one looks like. Sorry about that.
While you do that, so in K-frames, you can create the structure and the behavior.
Yeah, you really have a lot of
K-frames?
control
Okay.
to do just about whatever you want. I mean, in accordance with the rewrite rules that you have in K-framework. Yeah. So I mean, you'll see in this the way that I'm using this here, right, is basically assuming that X is a name variable and also that Y is a name variable. So it's not going to work out the way that I have it written here because they need to be process variables. So basically, if I throw some quotes in front of those things, then now it should work, right? So here's my com.type. So let's just go back to this and try to rerun that one. So com.type, this should run now. Okay, so clearly some more complicated structure in a term like this, where there's like some sends and quoting and pars and receives going on with some binds. This is clearly a more complicated structure than like the integer 12. So of course we're going to get some more complicated structure in our structural type than we are for something like just the integer 12. Let me make that a little bit bigger. So basically, I mean, what this is doing is it's essentially just saying like, okay, so the top level constructor is a par, because we had like a send parred with a receive. So the top level constructor is the par, and then the par has, two things that you put into it. One of those things is this send, which goes all the way to here. There's some other structure within the send, like for example, I'm quoting some process variable, which I called X, and then there was also a nil in there that was being sent. And then I also had this receive, which is this, the rest of this structural type here. So it specifically tells me, okay, it's a receive, but even better than that, it tells me specifically it was a linear receive. So it was just like one receive that's consumed one time. It's not like a peak or a repeated listen. And within that, specifically the pattern that we were listening for was some quoted process variable, et cetera, et cetera. So this is just telling me literally something about the structure of the term that I put in there. It doesn't tell me anything about like, here's a possible reduction for this thing, because if we look at it, I mean, so with this one, there won't be any reduction because we're listening on a different channel than we're sending on. But for example, if I were to change this to like something like this, I can still ask for the structural type. It'll give me the structural type. And again, it still will not tell me anything about like, will a COM event occur? And certainly a COM event will occur. Right. So, I mean, there's the structural type for it. We could go through it like character by character, right? Top level constructor is a par, there's a send, there's receive, et cetera, et cetera. And certainly there's a COM that's happening here, and ultimately this will just reduce to nil, and that's really all that's going to happen with a term like this. So that's kind of like capturing the structure, right? Just basically like syntactically what's happening. But then we also know that there's behavior associated with a term like this. So I can show you what I've done in terms of being able to actually capture the different behaviors. So I think here, let me show you what we're actually looking at in this one. So this is COM tuple.
So you already went over this. Can you repeat what a par is? Me defining the type.
Yeah. So in the type, yeah. So par is just like I'm running two things in parallel, right? Like what two things in parallel am I running? So each one of these, every time you see the word type with like the square brackets, there's always going to be 3 entries because I'm defining a binary tree. The first entry tells me like that top node, and then the 2 entries tell me kind of the branches from that top node. So this one is basically saying like, okay, this term has as the top level constructor the par. So I'm going to be running 2 things in parallel. I'm not sure what they are yet until I get deeper within this thing. So then the first thing that I'm running in parallel is this send, right, which has this particular form. It's like specifically send on the channel at X, and I'm specifically sending the process nil. And then the other thing in that parallel composition was a receive, and specifically it's like a linear receive. I'm listening for this pattern at Y on this channel at X, and then the continuation is nil, basically.
Holy crap, that just like blew my mind.
well, sorry, Jay, what did you say?
Oh, I just said they need a pretty print.
Yeah, I know. Well, yeah, if you know how to do that, that'd be great. I could definitely use some help making this look a little nicer. And honestly, at this point, like I've been working with it so much that I'm just like typing this in by hand if I need it, because it's like too much of a pain to like go to my S-type definition and like run this code and then copy and paste it back to like some other thing. So I should probably figure out a better way to deal with all of this. But yeah, so let's look at the this code that I wanted to run for. Actually, you know what? Let's look at the not that it really matters, because like here I'm just sending some tuples, and here I'm just sending single processes, but they're fundamentally the same thing. So basically, what I want to do is put in a term like this, and so this is a little bit confusing because we're looking at both implementations that I'm working with now. So you'll see I didn't quote any of these variables. These are all named variables in this particular implementation. But either way, I mean, it doesn't really matter so much. So here's the term that I have, right? So like I'm sending some, I'm sending 1 on the channel X, I'm sending 2 on the channel X, et cetera, et cetera. I'm doing a listen on the channel X and a listen on the channel Y, right? So I'm sending 2 different things on X. So 2 potential COM events could occur between this listen and these 2 sends. And then 1 COM can occur for this send and receive on Y. And so basically what
sorry, you said 2 COM events.
Yeah. So either this one, the one could be
only one for X. Only one for X.
Yeah, 1 of 2 could happen. Yeah, exactly. So so basically what will happen is we'll have a few different possibilities here. So the way that I have this thing working currently is it will do 1 COM event and then just like put everything that hasn't been reduced in the COM event like back into a parse. So I'll show you what it will do, because essentially what this implementation does is it parses this and it says, okay, here's a send. I'm going to populate a particular send cell in my tuple space. Like here's a send. I'll make another send cell in my tuple space. Now I have 2 send cells there. Here's another send. Now I have 3 send cells there. Here's a receive. Now I have 1 receive cell and 3 send cells. Here's another receive. Now I have 2 send cells, 2 receive cells and 3 send cells. And so it'll like aggregate all of this stuff in the tuple space, and then it'll do some matching and basically say like, do I have any channels in the send and receives that match up? If I do, put them together and basically, do the continuation with the substitution the way you're supposed to. And then once 1 COM event occurs, basically like stop and then tell me what is left. So I'll show you.
Can I ask you about that? So you're saying that you have some kind of rounds in com events.
Yeah.
And in a sense, you don't want to go depth first.
Sorry, what was that?
You don't want to go depth first in a com event. So when you find com event, you have continuation process on an input, but you don't evaluate that process. You first want to find like all the other com events on that level, or I'm not sure how to express it.
Well, so for example, so one possible result from running this program would be, so this send of 1 on X could com with this receive, right? So then the continuation is just going to be, start at 1, which is just 1 for all intents and purposes, right? So these, so the send of 1 on X and the receive on X will com, both of those terms will dissolve, and then basically we'll just be left with a 1 in place of those two, and everything else still stays. Nothing happened with those terms, and so that's exactly one of the potential results that we get from it. So we'll have 3 potential reductions here.
Okay, but theoretically, you could send something on Y on the first 4.
Yeah.
But you will definitely not make this send before you make a com event for the first Y send, right?
So you're saying, if like in the continuation there was a send on Y or something like that.
Yeah.
This
will definitely this continuation, this send cannot be matched, make a com event with this first 4.
Yeah, not in a one-step reduction, right? Like
so this Y that sends Y will always win.
This Y, yes, will always win. Yes. Okay. Yeah, so this is just one step like com, this is like a one-step modal operator basically, right? Like I want to say if only one com event is allowed to happen, what are all the possible reductions of this particular term? And so my thinking was basically like, if I could track it for 1, then maybe I can figure out how to track it for just whatever number of reductions I want to see, and then I can kind of go from there.
But only reductions in a par. You don't go like nesting inside. You can say, well, I will parallelize everything in one par, but I cannot parallelize inside nesting. So this is like a different.
Yeah, not yet at least. Yeah, right. So in only one step, we don't have access to anything in a continuation, right? Like none of that stuff is in a position to
but my question is this possible or desirable, or what is the correct behavior? This is my question.
The correct behavior in which situation?
In this situation, if the first 4 have sent on Y.
Yeah. Okay. So it's like 4. Well.
Yeah.
4.
No. Send on Y.
Send on Y. Okay.
Yep.
So this is just a send on Y. So nothing with.
Yeah.
2 or whatever. Yeah. Okay. We can run it and see what happens.
So, but this send on Y will never compete with this first.
Yeah, that's right. Because all I'm capturing here is one com event, right? Because the only way I can access this stuff that's nested in a 4 continuation is if I do a com event on the channel X and then also allow another com event to happen, right?
But this will not be allowed in rolling, right?
Well, I mean, this is not happening currently with what I have right now.
But you're saying you will allow that, or what is the correct?
Oh, I'm saying I'm not 100% sure what the correct thing is, and this is just like an attempt to get some sort of behavioral types. Yeah, so let me show you.
I'm looking for this answer. So.
Yeah, well, me too, man. Me too.
Okay.
So let's see. Well, now I've changed it, but it should be just fine. Let's go ahead and run it. Yeah, and so we can look at the code for this stuff if you're interested in seeing what it looks like. Oh, I actually ran a different one. Whoopsie. Let me go back here and not do it with the tuples because we just changed it. So I want to see how that works. Yeah, all right. So what's happening here is, so it's telling us there's 3 possible reductions for this, which is essentially what we would have expected. And so this is giving me all of the possible final states of my, oh, that's a little bit strange. It's giving me all
it's only
the,
one.
What's that?
On the screen, it's only one result.
Currently. So you see, it shows me the result is k equal to, well, I have this configuration as a result, or I have this configuration as a result, or I have this configuration as a result. So let's just talk about each of those, right? So so in this first one, basically what happened was that first send on X, which was a send of 1 on X, was the one that eventually commed with the listen on X. Right. So then we end up reducing those terms. The continuation was just a 1 ultimately. And then the rest of the stuff is, still here, whatever order, it really doesn't matter what the order is. But all of the other terms are there. And this is just telling me basically that one comma event happened. Right. So this how cell in my reaction structure here is just telling me how many comma events happened, basically. Like how many matchings of send and receive cells did I do before producing what you see in this reparse cell. Yeah, so like I said, in this first result that it's giving me, what happened, it's a little bit weird that it didn't do this one. Maybe I didn't save it. But either way, what happened was, this is what it actually ran with star Z. But either way, what happened was this send of 1 on X commed with this listen for on X, and basically 1 was the continuation. So the rest of the terms should be like send of 2, a send on Y, and a listen on Y.
And why we didn't see your change, like a send?
Yeah, I don't know why that didn't happen.
Maybe you didn't save it.
Yeah, I may have not saved it. Let's see. All right, now let's send, actually, but you know what, let me send a 3 just so it's not sending anything that's the same. All right, let's see if that's the wrong one. Yeah, let's see if it does it now.
This is cool. You get all the possible paths.
Yeah, and I think there's some more complicated searching that you can do that I'm not sure how to do, and this is a little bit weird because now it's actually running to 2. That's strange, but
well, that's fine for the 1 or 2, right? You get one or the other.
Well, so there's a little bit. Oh, this is really weird. All right, yeah, let's see what happened. Oh, interesting. Okay, so so it turns out, right? Of course, if I used the message on Y to do that comm event, well, this one will never be freed, right? So that's the only comm that can occur, and so it's like returning the rest of the terms after that comm event. Now let me just tell you, right? The only way that it will regather all of these terms here in this cell is if this one is 1. I only wanted to capture the 1-step reductions. So that's why this one will have something in this reparse cell, and this one, well, everything is still populated in the tuple space actually. But either way, what it looks like happened here was we actually did the we used both messages on Y because this 3 was also a message on Y. And what will happen is if we consume a message, if a comm event happens, it'll basically match something here in this send cell. So it'll take one of these like teal or cyan send cells, right? Like for example, here's a send of the message, string Y on the channel Y, whatever. And basically it's going to match one of those guys with something in the receive cell. Well, clearly there are nothing in the receive cells here, so there's no more matching that can happen. And that's why this is a final state, apparently. but it's telling me 2 COM events occurred here. So apparently the 2 COM events that occurred was, so we consumed the message 2 on X, right? That's not in the send cell. And because we consumed that message 2, let's go back to our term. Because we consumed this message of 2, that also gave us access to this message to consume, which looks like actually happened in this case, right? Because I have this 3 up here in my thread cell now. So I take the continuation, throw it back up into like the thread cells, which is basically like what corresponds to like activity here. Because essentially these thread cells are originally populated, and then they dictate how the send and receive cells are populated in the tuple space, and then that dictates the matching for COM events, basically.
So now it's really, in this case, it's depth first.
Sorry, what was that?
In this case, it's depth first. For after the first COM event, continuation is executed before the
right. That's right. So two COM events occurred here, which have this counter, so we know 2 COM events occurred. And specifically, the 2 COM events occurred is that the message 2 on X was consumed, and then that message 3 on Y was consumed, and that's why the 3 ended up here. So that was the second result it's telling us. The third result, okay, basically the same thing, except instead of consuming the 2 message on X, it consumed the 1 message on X. But basically same thing happened. I did 2 COM events here. That's why we got the 2 in the house cell. And then the 3 was, again, the continuation in that case. Oh, yeah, right, of course. And then I could consume the message of 2 on X. And then now it's, so this message of 3 on Y is now free from being nested in the 4 continuation, but it wasn't the one that was actually matched in this case. It was the string Y as the message on Y. And so that's why that's up here in the thread cell. And so 2 COM events in that case, pretty much the same thing, except the message 1 was consumed on X in this case. 2 COM events again, and it's saying that's all that's possible in this situation. Yeah, so that's interesting. So I thought I had.
This is great.
Oh yeah, you like this? Cool.
Yeah, cool. I mean, I was asking only one of these solutions, but you have all of this.
Yeah,
so
it's
you could just say rolling works like this. So we will say correct type is this, and this is not correct type.
Exactly. Yeah. So let me show you how it works with just the 1-step stuff, which is what I was going for. And I'm actually a little bit confused as to why it did the 2 steps there, but I think I might know. I think it's because I allowed it to go past 1, where like the first time I did it, I was like, okay, if it ever gets to 1, like everything completely shuts down. But I have another rule that also says like, well, just increment that house cell by 1 every time a COM event occurs, basically. So those 2 rewrite rules might be competing a little bit.
But can you just say, can you just leave your definition as is, because it's like more general, and just say when you compute, you just filter for how 1.
Right, exactly. And that's exactly what I would like to do, is like write a function that's basically like, tell me all the 1-step reductions, tell me all the 2-step reductions, 3, etc. Basically, that's ultimately what I would like to do. So essentially, what I've achieved here, right, is like specifically with 1-step reductions, I can capture all of them, and even better, I can have the resulting term afterwards too. So like in this case, right, it looks like the message of 1 was consumed on X, and so that's why it's now here as like the continuation after substitution in the COM event. And here's the rest of the stuff that had nothing to say in that particular COM event that happened. Basically, same. Yeah.
Is a part considered a behavioral type?
Is part. So I think what people mean when they say behavioral type is like this ability to just start from this particular term and then say like within, you know, X amount of steps, like here are all of the possible reductions in X amount of steps, basically. So like what I'm saying is in one step, there are 3 possible reductions from that. And even better, here are the 3 possible reductions. Like here's one with this 1 here and still a listen on a send of 2 on X. And then here's another one with this 2 now in parallel and this send of 1 on X. And then here's the third one where it was actually the Y channel that had a comm. And then this, you know, this will work even, so I have some examples where basically doing the same thing, but instead of just sending single processes, now I can send like, you know, several processes. So something like this, you know, so instead of just sending a single one, I can send like, you know, a tuple or, you know, however many numbers or, you know, processes I want to send, doesn't matter. And this will still give me more or less the same exact behavior.
Can you say what is the difference between tuple sending and only one?
Yeah, so really nothing. I mean, there like effectively there's no difference, but the way that I have to handle it in the implementation is quite different actually, because I have, you know, now several things in this, you know, in the tuple to actually like keep track of, and, you know, what order do I put them in and how many of them are there and that sort of thing. So like, for example, one thing that I have to know is like, if I'm listening for, you know, a single process to come in here, and I'm sending this tuple, I want to be listening for like 2 different processes, so I can bind the 1 to the first one and the 1 to the second one, really 2 different names. But here, doing something like this, you know, listening just for a single name, if I were to try and send, you know, 2 processes, well, like neither of them, you know, no comm would happen in that case. Like, so the only way a comm will happen here is because I'm sending a single process and not like a tuple of processes on Y. And there's like a really stupid distinction between like when I send something like, okay, so there's a distinction between sending, you know, 2 processes that are separated by a comma and sending like a 2 tuple of processes, because this is now just sending a single process. It's really stupid, but this is now sending a single process, right? That single process is the tuple 1, 1, whereas what I had written before, this is actually sending 2 processes.
Oh, did you change now? So we have polyadic.
Well, so everything is, I mean, I don't know. I don't know what the correct terminology is, but so the way that it goes is how I'm saying, right? Like if I write it like this, then this is actually sending 2 different things, and I expect to have 2 bindings that'll happen here. However, if I send it with just, you know, if I send a tuple like 1, 1, now I need only 1 name to bind here because it'll bind to at this tuple.
But you could also put Z1 and Z2 in the brackets and accept.
Yeah, right, exactly.
Maybe not now, but yeah, the idea is.
Right. Okay. Yeah,
so you have this distinction. You have this distinction.
That's
because
right. Yeah.
You said that you will not make this distinction. So.
Well, so the problem is that tuples are processes. So like, so in this case, I'm not sending a general process. I'm literally just sending a tuple, right? And that tuple consists of these 2 processes, 1 and 1. Whereas when I write it like this, I'm now sending the process that is the tuple. And so it's like a little bit confusing. But so yeah, so this is kind of like the polyadic send, and then this is kind of like the monadic send, I guess, if that's the proper terminology. I'm not even really sure.
I'm agreeing with Joshi that I don't see what the benefits of this polyadic.
Oh, and this is even less. This is even. I've tried to modify it to make it more monadic than you know, it was before, and this is the result of that. You know, so. It's a process, I guess. But yeah, so I guess the reason that I've been keeping those separated is just because like so when I put in something like this, then I know I'm expecting 2 names to bind. And whereas when I put in something like this, like I said, I'm only expecting 1 name to bind in that particular case. Or like you said, you can put it at, I'm expecting specifically a tuple pattern, and then it's going to bind those names in the tuple pattern, essentially.
Yeah, or can you only have 1 arguments in a send and receive? So if you want to send 2 processes, you can just send.
So it's a little bit silly, but there's 1 argument, and so there's 1 argument in this send currently, and watch, there's 1 argument in this send currently. But now the thing that it's sending is this tuple, right? Whereas so technically I'm always just sending a tuple. It just turns out that this send here, it's a tuple, but the tuple it's a 1 tuple, and that 1 tuple has a 2 tuple as the only entry.
Oh, but is this just a complication without any benefit?
Yeah, probably. I don't know.
I'm really wondering because we were discussing this, and in Python it's not implemented like that. In C# it's not implemented like that. So
yeah,
I would like to know the reason why.
Right. Yeah.
Cool.
Well, I don't think there's a good reason to keep the distinction other than that's currently how it's working, and I haven't done enough to only make it work one way or the other, basically. But yeah, so currently with the way that I have this set up, like this term would not come with this term, just because here I'm listening specifically for 2 separate things, and here I'm only sending 1 2 tuple, right? Whereas if I were to do something like send, this 2 tuple by itself, right now it's kind of like I have access to each of these individual things, and I expect to bind each of them. But either way, so like we were talking about with the other case, right? Like this one, so I ran this, and it does essentially the same thing, right? It lets 1 comm event occur, and I'll look at all of the possible reductions from that 1 comm event. So here we had a comm on the channel Y, and so we have this continuation of Y, and then the rest of the stuff, nothing happened with it. Here we had a comm event with with that message 1,1. So this 2 tuple 1,1 is the continuation from that, because basically all I was doing is saying like whatever message I get on the channel X, like basically just display it as a tuple and keep the order and everything. So here I'm getting exactly that as the continuation, and the other terms are present, and then here it's the 2,2. That's the continuation from that. So yeah, I guess the so I mean I guess the nice thing here, right, is that like everything is recollected for you here in this reparcel, and so I have literally all of the possible reductions of that term listed on the screen.
Yeah, this is great. And so now the next step is for you to define somehow what is allowed reductions in Erlang. So you can say, okay, these paths are like valid, these paths are not.
Yeah.
How this is done? Just, I mean, in general.
Well, so what do you mean by allowable reduction paths exactly?
I mean, now you have all possible reduction.
Yeah.
But maybe you don't want to allow these reductions of nested processes without first reduce all the reductions that you can have on this level, on this first level, before you go in the nesting process.
Okay. Okay. So you're saying like do all the reductions of like anything that can reduce with these three sends before like maybe there's a send, coming out of here or something.
I mean, all in this par that you have.
Mm-hmm. Mm-hmm.
And
Yeah. Is that how it actually works in ruling, or is it like the second, so if there's like a send in this continuation, that could come with something else. And something comes with this listen, so now that's available. Now isn't that thing kind of promoted to like the level of everybody else in this part expression? I mean, that's how I understand it, at least. Maybe I'm wrong.
Yeah, but I don't know exactly. This is why I'm asking you. But
yeah. Okay.
I think that currently it's working just like that. First, all the par are like reduced, and then all the nestings. And
oh, really?
Because I'm thinking that maybe we don't want to reduce indefinitely in one after the first come event, because maybe you don't expect this.
Yeah.
I mean, you have some code deeply nested and some channel that listen on the outside.
Right.
You don't expect that these two will happen.
Yeah.
So, but I'm not sure. I'm not sure.
Yeah, I mean, I want to say, so my understanding was basically that, so everything that's paired together is just thrown into the tuple space, right? So like all sends are equal, essentially all receives are equal. And like if a COM event happens, like now it's processed, but then what is it processed into exactly? I mean, it's like whatever the continuation is after substitution, but then what do we do at that term? Like, does it not just go back into the same tuple space, or and that's essentially what I thought, and that's how I've been implementing it, and that's exactly why I'll have it. Well, I guess this is a particularly bad example, but that's why. Dang it! Where was it actually doing some of the continuations? Basically, all I wanted to say is that's why when it's doing. When it's doing the continuations, it just will throw the continuation back up into the thread cell, because then the whatever's in the thread cell will then be just put back into the tuple space essentially. Yeah, whatever. I didn't find it.
Because I'm thinking how this how should I implement tuple space? So you said you have a set of sends, a set of receives, and then you
multi sets of each of them.
Yeah, exactly.
Yeah.
So you said after I done the first reduce.
Yeah.
But you have other reduces that you can perform.
Right.
So is it right to put a result from the first reduce immediately in the tuple space without reduce all the other possible candidates?
Yeah, right.
Because
well,
this is like a very, very different way of reducing. I'm thinking that it's very different. Maybe it's completely not.
Yeah, well, like I said, that is my current understanding of the semantics of the tuple space and how comms are processed and handled within.
And now you don't have to specify that. You just say there is all possible way to reduce.
Right.
And now I'm asking. Now you need another set of rules that will specify this way of reductions are invalid, and this way of reductions are valid for all, right?
Yeah. I'm not off of the top of my head. I'm not sure how I would do that, but yeah, basically you can just say like if anything is well, actually I think maybe that could be pretty easy. So instead of just like throwing the continuation from any reduction back into the thread cells, which then just filter back into the tuple space, like maybe put it somewhere else. And then like once all of the possible like top level reductions are done and I gathered all the continuations and nothing else is happening, like then put everything back into the tuple space maybe. I think that could actually be pretty easy. I mean, if that's the way things are supposed to work, I think I can tweak it and it would be really easy to do. But like I said, currently what I have going is like everything. So like all of my, sends receives, like once they match, like they just populate this reaction cell. And this reaction cell is basically making it so that I can do, like, regardless of if I'm sending, one name or one process or many processes, I can deal with the COM event essentially in the same way. Like I just put all of the, stuff that needs to go into the continuation, like what names am I binding to and like what, names am I putting in for those. And, so like, what's the substitution and what's the process that I'm substituting in? Once I know that information, like I have enough to actually carry out the substitution. And then like whatever I do with that information is I guess a design choice basically. And so like currently I'm just having that stuff. So this reaction cell basically like, once there's only a single process, basically once there's only a single substitution to make, like one name, one process, it's just going to throw that resulting substitution back into the thread cell, which then will process in the tuple cell further, or the tuple space further.
Okay, and you said just a question about the reaction. You said you have a reaction just to collect all the binding arguments.
That's right. Yeah.
If you have only one argument, you maybe don't need a reaction. You can after a COM event, you can immediately put it to tuple space and continue.
Right. Yeah, exactly. Okay. Yeah, because the only issue here is like, so I have all of this like data in the send and receive cells individually, but how do I rewrite that information so that I know that I'm like, using the head of the process list that's there, whatever. And the best way and because like if I keep it in a send cell or a receive cell as I'm rewriting it, well, then it puts it in a position to match with other things that it shouldn't match with. So this was kind of my solution to that, is like, well, just have like another cell that I put everything into that will completely match and do all of the substitutions. And then like that final thing that comes out of that, like I'll just throw that back into the tuple space essentially.
I'm thinking how can this help me to implement this in the Haskell?
Yeah.
Because I'm a little stuck on I'm thinking how to implement this, and
maybe the answer is don't walk this line between monadic and polyadic and just stick with the monadic and maybe things are easier.
I support that idea.
Yeah. Well, I thought I was doing that, and then Thomas Lobb pointed out that maybe I'm still not doing that exactly. So I have some slight modification to do it, and maybe I can even get rid of this, which would be great. But so I think so Joshi, so we're talking about like, so when you have like
just in time to hear the two alternate semantics.
Oh yeah, okay, cool. So
my understanding is the same as what you described, Isaac, probably because we developed that understanding together at some point.
Right. Yeah. So I don't so like I know there's the process pool, right? That so the process pool and the tuple space, those are like the two entities or whatever that you talk about with the tuple space, right?
Two parts of the state machine. Yeah.
2 parts of the state machine. Yeah. So once you have the COM event happen, like information goes over to the process pool to like actually do this substitution, right? So this is almost like what's happening in my reaction cell here, right? It's like we've matched a send with a receive. Now we're going to take all that stuff over to this other place and like actually do the substitution. Mm-hmm. but once we do that substitution, it just goes right back into the tuple space, or what exactly happens with it?
Yeah, well, so once you do the substitution, like basically you sub something into a continuation, and so now that continuation is a concrete process, and in general, it's several things part together, right?
Yeah.
So you just, my understanding is the same as yours. You just look at all that stuff from the now concrete continuation, and you sort it into the proper place in the tuple space, which is either as a send, as a receive, or like it was a ground term, so we're done with it.
Yeah.
Put it anywhere.
Yeah, my ground terms currently just get stuck in the thread cells, but that's something I could change, I guess.
Tomislav, your semantics that you described seem interesting and also valuable though, right? Just different. And I think it's actually like every com that's allowed by the semantics that Tomislav explained is also allowed by the semantics that Isaac explained, and then the one that Isaac explained just also, at least in general, not always, has additional com events that are also legal.
Yeah. Right.
Josh, did you see in this this sample that Isaac was showing?
I saw part of it. It was happening right as I came back.
Because
I saw you can search for the different quiescent states, which is pretty badass.
Yeah.
But I want just to be clear that if in this example, if here we have sending on Y, what with current implementation of Roland will do?
Co-op Roland interpreter?
Yes.
So let's see. Well, it looks like we could have a com event on Y, but I don't think your semantics are totally the same.
My question is it possible that you get this for Z from Y, this last input? Is it possible that this can be reduced with Y send that send 3 on Y?
Mm-hmm. Yeah. Yes.
Is it possible?
I think so. Or we could try it a bunch of times and see. My understanding is that it is. I don't really know. Well, okay. So let's see. Let's ask this question. What if we make it a little less non-deterministic, right? So what do we need for that send of 3? Well, what if we just get rid of the Y bang Y?
Yeah, get rid of this.
Yeah. Yep. Then definitely we agree that the send of 3 on Y will com with it, right? So in either semantics, this is, so the question is is it necessary that receive on Y already be reduced with this send that he just put back before?
Right.
Yeah, I think the way Isaac explained it is right, but honestly, those are both interesting, and I don't have a specific source that makes me think that.
Yeah, I don't know what the advantages or disadvantages of either approach are, but just specifically, just going from really naively, just from the com rule defined in the row calc paper, it should be the case that it's possible for this for to be consumed first before this send on Y is consumed. And then these guys are on the same level at that point. They're both just there, because this is just a continuation, so it'll end up somewhere in this R, and then it's on the same level as the other send on Y. So
that's right. The row calc paper, I think, is the right place. I didn't think about that. That's a good point.
Yeah, I mean, I've been trying to model things from that, so at least I know, because at least I know that's correct and not really disputable. So.
Yeah, because so in fact we talk about it as reductions, right? Com event is the one reduction rule. So you have some tuple space. Yeah. In general, there's a set of com events that could happen. So you choose one, you reduce it, and now you have a post state, and the same rules apply. So some com event is left over from before that was possible in the previous state and is still possible, great. Or if some new one comes in there that's now possible and wasn't before, I think that's also okay. Right, because every com event is a state reduction. Then you're back to tuple space.
The com.
Yeah, this totally makes sense. Yeah. I was really just thinking about can you reason about what will happen if you just without counting all the com events. But because I'm not expecting that this will that I will get 3 for y.
Yeah. Yeah.
Because
So you're saying
it's
you're
nested
not
and-
expecting that you would actually see this 3 in a continuation.
Yeah.
Yeah. Well,
But I don't have
certainly,
anything
like just like
hard with.
so yeah, probabilistically, it's more likely that this one is consumed, right?
Yeah, but you're saying it's not necessary that this will be the case.
Yeah, it's not necessary. It's just more likely, right? So like if we were to run this code 1,000,000 times, like the vast majority should have this one being consumed, but some of them should have this one being consumed, I think. Right? Because like just from this level, like so something has to happen, right? So certainly ACOM could have things that we could com with, and we have no preference of any of them. It's like 1/3 chance that this one gets consumed, but it's like 2/3 chance that one of these gets consumed, and then this guy appears, and then there's like a 1/2 chance that this gets consumed. Oh, so maybe it's 1/3 in each case, huh? Interesting. Maybe it's equally likely. I don't know. We need to run this code 10 million times.
Yeah, I'm just thinking that you have one more reduction, so it's slower. So
yeah. I don't know.
Real physical reason, but yeah, it's not part of the semantics.
Yeah. Well, I guess that's another question, right? Like while one of these sends on X is comming with this listen on X, and this thing is being returned to the tuple space, like can this guy com with this listen? In the whatever millisecond or femtosecond or however long it takes for like that information to be processed. I don't know.
So you're talking about a state transition system here. So we could draw the state transitions as a graph, and if you think about one reduction happening simultaneously while another reduction's happening, that means that you have 2 reduction arrows going from the same pre-state into 2 different post states. And so then if you want to bring those back together, now we have the interesting problems that our chain actually has, right? We have to decide, did those conflict with each other or do they commute? And if they commute, then we can bring them back together. Because like, for example, you could ask that same question, like, does imagine the XBang 1 is comming, and then like in that, short amount of time, the XBang 2 is also comming. Well, those aren't both possible, right? They're both possible from the same pre-state, but they can't ever go into the same history.
Right. Yeah, that makes sense. Yeah, right. Because only one can be consumed.
Yeah.
Yeah, I'm thinking in a sense of you now have current state and you're going to make transition. Mm-hmm. So you have a bunch of COM events that you execute. Then after that, like this is one snapshot. Then you collect all the other candidates for reduce, and then do all of that, and then after. Mm-hmm. But yeah, this doesn't make too much sense, because you'll be waiting for some events to happen.
Yeah, I like to think about it like a cone, and there's like futures, I mean, kind of like how they describe Casper sometimes. But it's like, there are several possible COM events that can happen in any given state, and then you can ask questions like, given different COM events happen, like, do they have a common future? Is there like a way to do different, sequences of COM events and still end up at the same point or something?
People do that in quantum, in relativity too, where they talk about like there's this. It's like a cone that has the vertex and expands out, and like these are all your possible futures, and these are all your pasts.
Yeah, like, the COM future
over here, but definitely they are not in the future or past of this state because they're outside of the cone.
Right, yeah, it's the COM future. Yeah. So I don't know. Do you guys want to see like some of the code that I wrote up for it was pretty cool, honestly. Oh, and I have some more type inclusion stuff, but I'm not 100% sure like what the pattern matching should be doing. I think what I have been building is way more general than the pattern matching that's actually working in Rolang. But I as a general principle, I think that's okay to like build something more general and then, you know, restrict it afterwards, because now I have something that's like maybe kind of cool. I don't know.
Dude, Isaac, build something more general and then convince those clowns to build the same thing.
You're like, yeah, I was looking at your Rolang and it sucks. What is this?
Hey, but on a more serious note, I'm curious, Isaac. It might be valuable for the dev team to see some of this work you're doing in the same way
okay.
you us every week. Those guys might benefit from it.
Yeah, I definitely need to have some conversations with them.
Because my questions are exactly for that purpose.
Yeah, cool, man. So here we go. So ultimately, I'd like to define some Boolean relations that can just tell me, like, is this thing a reduction of this other thing? But I haven't done that quite yet. So I added, so all of this configuration is identical to the other implementation that I've showed you before. Up to the reaction cell, the only thing that I added was this, you know, like how many COM events have happened cell. And like I said, basically, like once that thing ticks to 1, then it initiates another event, which I'll show you. And then there's this repar cell, which will like gather all of the stuff that's left over after 1 COM event occurs. And I haven't done anything. It would be like a place where I would collect all of the things, like as I'm consuming sends for like a join or something. I was thinking maybe I'll store them in this. If it doesn't completely consume all of the listens, then like maybe it puts them back into the send cell, or, you know, something along those lines. I haven't, but same par semantics. Like, so it just generates a thread cell for each parand. Same, you know, generate a send cell for a send, a receive cell for a receive. The reaction stuff is doing exactly the same thing. Now the only difference is like here, basically what I'm saying is like once I match a send and a receive, I'm going to consume those things, and I'm going to populate this reaction cell, which needs to be empty when I do this consumption of the send and receive stuff, basically just so I know like from events have actually like fully executed and were put back into the thread cell. And I increment the, you know, how many COM events happen by 1 when a COM event occurs. That's pretty straightforward, I think. More or less the same thing here, but now I'm keeping track of like multiple quantities. So this is, I guess, the polyadic nature that I still have in my implementation here, is that I'm keeping track of multiple names and processes. Yeah, and so pretty much same thing happens if a COM event happens, increment how many COM events happened by 1. Basically, so the reason I was confused with how to do is because essentially once this reaction cell, once the how cell in the reaction cell gets to 1, what should happen is basically anything that's in the thread cell, and there will be something in a thread cell because, well, a COM event just occurred, and so there's a continuation in the thread cell for sure. We're going to take whatever that process is and just, you know, put that process into this repar cell, which was empty to begin with. It's empty from the beginning. So then once there's something in this repar cell, though, what's going to happen is anything that's left over in the thread cells, if there is anything, we'll just par it in with what was there in the repar cell to begin with. So basically, I'm like collecting all of the terms that are still lingering in the thread cell. So if they were inert, if they were like evaluations or like ground terms or something along those lines, like they aren't sends, they aren't receives, but they're still processes, like they're hanging around in the thread cell somewhere. So what I'll do is just gather all of that stuff in the repar cell, basically by paring it all together. And then basically the same.
Oh, sorry.
Mm-hmm.
So you're saying that you have tuple space for send and receives.
Yeah.
But you're not putting discontinuation process inside tuple space.
So everything gets put into a thread cell first. So like if it's a send or a receive, then it's further processed into a send or a receive cell in the tuple space. If it's some like inert thing or a ground term, then it just sits in a thread cell. I first just like make another cell in my tuple space that's like just ground terms or whatever. But I just have them go back into the thread cell. And the reason that I have them go back to the thread cell is because like, well, if there's a send or receive there, when it goes to the thread cell, then it will be put directly back into the tuple space, the way it was originally put into the tuple space. So yeah, basically same thing with like.
I'm thinking if I have a tuple space, like some multisets, I also. I mean, I can after com event, I can it's just evaluate this process, right?
Yeah, right.
And after I evaluate if this is send or receive, I will put it to tuple space. If not, it's just evaluated and that's it.
Perfect. Yep. Okay. Exactly.
Okay.
Yeah.
Cool.
Yeah, and so that's why for example. Well, again, I'm not really showing what's left in the thread cell here, but the reason that this one resulted, and the reason that this one is literally the first thing here is because of the semantics that I have for reparring all of this stuff, right? Basically, that was the only thing in a thread cell. That was the only thread cell that was there had one, because it was a continuation from something. So it was like a comma event happened, the continuation was one, so one went back into the thread cell. If it were a send or a receive, it would have tried to put it into the tuple space, which it would have tried to put it into the tuple space, but it wasn't, so it just sat in the thread cell basically. But once there's something sitting in the thread cell, what I'm going to do is start populating this repar cell basically. So it started off as empty, put whatever is there originally, that's my first thing, and then everything kind of gets parred in with it. So whatever was the first thing in the par. Not that it matters, but that's just how I have it set up. And so here I have a 1 as the first thing in my par, a 2 thing in my par, and the string Y as the first thing in my par. Yeah, so that's basically it. But I thought it was kind of cool because essentially it's like, okay, once you see that there's a 1 in this cell, like one comm event has occurred, like I somehow need to tell it to like start putting all of this stuff in the repar cell so I can actually like generate that remaining term, like whatever the reduction is. And so the way that I thought to do it was like, okay, well, a comm event occurred, like stuff is going into the thread cell anyway, so there has to be an inhabitant in the thread cell. So like whatever that thing is, it doesn't actually matter what it is, but if there's something there, then that'll be the thing to like initiate, like starting to collapse everything into back into like that reduced term. So that's the first thing that populates in the repar cell. Once there's something in the repar cell that's not just empty, then everything collapses into the repar cell basically. So once I put that continuation in there, then it's like, okay, whatever other stuff is in thread cells, put all of that in there. And then whatever else is in the receive cells, like put all of that stuff in there. Whatever else is in a send cell, put all of that stuff in there. And this is just like for polyadic or monadic sends and receives. But yeah, that's basically it. So it's like, it's kind of cool because I had to somehow tell it to begin. And the way that I tell it to begin is by populating with the continuation from the comm event that just occurred. There may even be a better way to do this. Actually, what maybe I could do, and this would definitely only have one possible step in the reduction, so only one comm event, is like once the comm event occurs, instead of throwing stuff back into the thread cell, I could have immediately throw it into this repar cell, actually, I'm thinking about it. And then that would immediately start that reduction, regardless of how many possible comm events I could do. It would always just stop at 1 at that point, I think. Yeah.
Oh, you're not you are now talking about the order of this reduction, right? You get all the reductions, but you're now saying what is the order of defining these reductions.
Yeah. So I'm saying like if. Sorry, I think I missed that.
You're not changing the semantics at all. You're just
so I would be changing the semantics just a little bit so that it would never go past one comma event. Basically, literally the second one comma event occurs, like everything just collapses and it tells me the reduced term. Whereas the way that I have it set up now, because I take the continuation and put it into a thread from the thread cell and put it into the repar cell, there's a possibility that I just skip past this populating the repar cell thing, because there's competing rules that are happening here. So like this is one rule that could happen once I have a one comma event. But there are other rules, like if I have something in the thread cell, for example, if it were like a send, then maybe that send is just like put back into the tuple space, and then another com could potentially happen because now I have nothing in the thread cell. So I think that's why I was actually getting 2 reductions in some of those cases, and it would actually like regenerate the term in the one case. But now I got to think of like, yeah, how do I tell it like go 3 reductions deep and tell me exactly the term that I from 3 reductions.
I just wanted to ask you why do you need only 1 reduction? But
well, yeah. So my thinking was basically like, if I could somehow figure out how to do a 1-step reduction operator, then I can probably just like compose them and get as many steps as I want.
Oh, you're breaking up. No.
Oh, sorry. Yeah, my connection's been bad today. I don't know.
It's okay. It's okay. Just sometimes I lose a few words, but yeah.
It's tough in technical conversations where every word has a lot of meaning.
Yeah. This is also true.
Right. I think this is why I had my video off earlier. I think it works a little bit better when I turn my video off. Yeah. What was I saying? Oh, so you asked me why I only did 1-step reduction, right?
Yeah. I heard your explanation. You want to compose it and.
Oh, okay.
In a sense, you don't need this.
Exactly.
You will not need this number of reduction, right? In the future,
right.
It's only 1, and right.
Yeah. Right. Exactly. I would love to have the modularity where I can put in an integer like 5. I want to know all possible reductions resulting from 5 comma events. Like tell me all of the possible 5-step reductions of this term, basically. So ultimately that's what I would like to do, given some integer n, like tell me all of the n-step reductions of this thing. And so I figured this was probably a good first step in that direction, like being able to just have anything to say about reductions whatsoever, and like how to actually capture that behavior.
And you can do it now. So right, your implementation works. But
yeah, right, exactly. So definitely I can get it with 1, and I think I can restrict this to literally only do 1. But once I have that, once it can stop all computation after 1 comma event and then tell me that reduced term that results from the comma event, I think then I can just then take everything repar cell and back through the tuple go event, and then if something happens, tell me the reduced term.
I was more thinking that what you already show us. You have all the possible reductions, so you can just filter out what is. Give me all the reductions that have 3 comma events.
Right.
Oh, yeah, right. Isaac, you already have all possible comm events and how many steps they took, or all possible reductions and how many steps they took, right? So you're interested in a subset of those where n equals 5, for example.
Well, so currently what this thing does is if one comm event happens, then it will print out that reduced term. But for example, like I said, I think the way that I wasn't super careful, and I think some of them are competing. So sometimes it'll actually go more than one comm event. But in the case where it goes, say, 2 comm events, it won't tell me that reduced term. It'll just be a bunch of junk in the send and receive cells, which, of course I can make a new rule that's like, okay, once this is, any number, then I can just collect everything into the reparse cell. But, I would have to do something to make that happen. Yeah, but currently it's like after one comm event, and if we're not in that situation where like another one just happens to to occur, then I will just have the reduced term here. Yeah, and this will show you all of the possible reduced terms. So the only thing is I'm not 100% sure how to just like ask, like, okay, is this a valid reduction of, started with, and just saying like, show me all of the possible reductions, and then like looking for it, by scrolling through terminal. So like maybe there's a way for me to just be like, oh, I know that this is going to be a possible reduction because I can just, check the result or something. But yeah, I'm not 100% sure how to do that yet. Does that make sense? What I'm saying?
Yeah. This is totally cool.
Yeah. Because like I said, the only way that I have. Mm-hmm. Yeah, right, exactly. Like, yeah.
Is this by simulation between 2 execution?
Oh,
these 2 processes. Because you want to know, are they the same? Are they going to reduce the same?
Yeah. Yeah, right. Yeah, I don't know if that constitutes a bisimulation. I'm not sure. Yeah. I mean, so the thing is like if K-Framework is capable of showing me all of these possible outcomes, there's got to be a way that I can then, like use one of the potential outcomes of this program, in some fashion. I'm just not sure how to do it. But yeah, so that's I mean, more or less what I was working on for the behavioral type stuff. I think definitely needs a little bit of modification, but I think the idea is pretty clear as what I'm trying to get at here.
This is excellent, and thank you for explanation.
Yeah. Oh,
it's really helpful.
Oh, absolutely.
I'm surprised how well I now understand your code in K-Framework. I was just listening to you for a few sessions, and I really understand what you wrote. So it's totally great.
Yeah, cool, man. Well, so I think I'm approaching everything in a really naive way, and so like I'm just trying to do everything as simple as possible because like I'm not a great coder, so like I'm just trying to think like what's the easiest way for me to implement this stuff because I basically know nothing. So then this is the result of that line of thinking, I guess. That's more or less what I have.
For me, it's like
really do you have, Tomislav? Do you feel like showing some? How much energy do you have? Do you feel like showing us some Haskell? I would love to see what you've done.
I didn't done anything really.
Oh, okay. I thought maybe you had. I thought it sounded like maybe you were working on comm events.
I'm thinking because I don't have time to write anything, but I'm thinking.
Oh, yeah. Okay.
And I have a question for you because I read something. Or I listened on some session, and I think you comment something with them, and you mentioned for tuple space, if you have two maps for send and receives, and you said this is not needed. You can only have one map and tuple and.
Yeah, I remember thinking about that, and I also was going back and forth about that the other day. So maybe we should just talk it through.
Yeah.
So,
wait, what was what's the question here exactly?
The question is, what's the best way or a good way to store the tuple space in memory so that you can quickly access the parts of it that you want to access?
And then how to find a match, and then misunderstanding.
So my latest brainstorm was that the tuple space would be so there's two ways to do this, right? You can either have a single map that maps from channels to tuples, and then those tuples, the tuple is a pair, right? So channels to pair, and then the pair is lists. It's a list of all the sends and a list of all the receives. So basically, like in a single map, you're mapping from channel to here. Hold on, maybe I can illustrate this a little bit better.
You have tuple with two lists for.
Yeah, exactly. So one way would be like tuple space has type map or of a tuple of prox. And then like prox. I think that probably would work, right? So like the left side is all the sends on, it has to go from, well, in my case, it just is from prox because those are also the channels, but would maybe be like names. But then the other way to do it is like tuple space is a tuple where it's a map from name to list of processes. So like that's your sends map, and then the same thing over here. This is your receives map. So I think what I did currently was this one, but maybe I like this one better, but I haven't decided. What do you think?
Well, I did the second thing. I was thinking about the second thing, and yeah. But
cool.
When you mentioned the with the tuple with the first thing, I was starting to thinking about this is also possible, right?
Yeah,
you're using a list for process, but this can be a set.
Oh, totally. That can be a multi-set. Absolutely. It can be a set. Yeah, multi-set. Yeah.
Multi-set. Okay.
In fact, I want to do that too. I just never got around to it. That's definitely the right way to do it. So
I was thinking.
Yeah, go ahead.
Yeah, please.
Well, I was thinking about how to. What I want to do is make a really nice debugging and interactive tool so that like I write some code, I click run, and it's almost like in an imperative language you can kind of like step through one line at a time. And so what I wanted to do is be like, okay, here's your starting tuple space, choose your com event, and then it says like, okay, here's the next iteration. What do you want to come next?
Oh, this is cool.
So my thought was what I had described. One of my biggest weaknesses is I love like thinking these things and describing them, and I'm crappy about coding them and being motivated to code them. But so like I was telling Isaac last week this I thought of where every receive is a join, right? And it's the normal ones are joins of a single action, and the more interesting like actual joins are joins of multiple actions. So the way this could work when the user is going to say like, what com event do you want next? They choose first of all which join, like which continuation do they want to run, and what are the actions associated with it, and then they choose a send to satisfy every one of those actions necessary to run the join. So regardless of which one of these data structures you use, you basically present the user with this entire list, and you say, what continuation do you want to run? And then you say like, okay, well, what names need to be satisfied? And so then you look them up over here, and you say like, well, here are your options for the send on X and the send on Y. Was that clear? I don't know if that made any sense.
Yeah, totally.
Yeah.
So I think there's a way that like even with the implementation that I'm doing in K-Framework, I think I can add maybe like one cell or like one line. I'm not sure how to do it yet. But where it can be like, okay, here are all of the possible like comms that could occur, like choose one, and then you can like tell it which one to actually execute. And then maybe, after processing, it'll tell you like, here are all of the possible comms that could occur, like go ahead and choose one. Is that kind of what you're talking about?
Exactly what I'm talking about. Yeah. Choose your own adventure. But right, like every time the reduction tree branches, the user stops and says which way they want to go.
Yeah, there's a way. I haven't done it with anything that I've coded in K-Framework yet, but there's a way to make it work with like standard in and out, and you can definitely have it display choices to make like that. That's that. I feel like it's something that's not working properly right now, but I've only tried to make it work like once really quickly, and it didn't. So I was like, I got other stuff to focus
never
on.
Enough.
Yeah, I know. I mean, compiling once is never enough.
Yes. So Tomislav, do you think there are advantages to one over the other? They seem basically equivalent to me.
Yeah, but I like the first one like more.
How come?
Now that it's only one map, and you just find the name and you have it. So
it's only one map. That's true. This one's only one tuple, though.
Yeah, but I would rather have only one map.
Oh no.
Yeah.
But the other one's a tuple.
Like computationally, they're the same, right? Like there's not going to be anything that's possible with one, but not the other.
But the first one is just a one tuple.
It's hidden.
But I was thinking about how to store. Sorry?
No, I'm kidding. I just said you could put parentheses around it. No, it sounded like you were going to say something meaningful, though.
I was thinking about storing continuations not only as a process, but as a function. As a custom function.
That's an interesting idea.
Because I was thinking, how can I do it quickly for first, but also how can I do it more like more direct. So if I'm storing not only process but function from process to process, I can return or I can for continuation I can have a function from process to a tuple that is returning something that is side effect and the resulting process. So when I find the match, I just execute the function, and whatever else is returned, this is my side effect, and the process is continuation, and I just continue. And
that sounds super interesting. Can you describe it one more time?
Instead of just collecting, just storing the process for continuation. I was thinking about storing the function that receives
like a callable thing. Like you'll be able to call it in the future when the continuation runs.
Exactly. I will call it when I want to reduce, when I have com event.
Yeah. Right.
And this function will return tuple, so I will have some kind of side effect that I can execute or collect.
Like debug, like printing notes that this particular com event ran, or like giving output to a user.
If I put this all in I/O, I can directly print to standard output, or I can have testing harness where I can collect all of these things in list and just print it and.
Sounds awesome. Like this is how Erlang becomes a real usable programming language, right?
Yeah, dude, that sounds really cool.
I was thinking on this in relation to this final and initial coding, deep and shallow embedding.
Yeah.
This is very nice if you want to embed language inside the language, because you have this shallow embedding, which is only a functions that manipulates the structure. So you have like a nice interface.
Yeah.
But I'm not sure that we need this in Roland, because we don't want embedded language. We want Roland syntax and straight down to tuple space.
Mm-hmm.
We don't care about embedding anything. So
well, I was thinking at some point, about like making the more primitive stuff like the string ops and the integer ops and stuff like that, like an embedded language inside of RoCalc, inside of Rolang, basically.
Mm-hmm. Yeah. I was thinking the same, and we really want just a straight way to call this function on our host language or our like a
like your meta language. Yeah. Okay. So you return this
like a big extraction.
So you return this continuation is stored as a function, and when you call that function, you get back then like all the stuff that needs to be added to your tuple space, and then the other element of the tuple is just some, in your case, Haskell thing that runs and has all the capabilities that Haskell has.
Yes.
Yeah.
And
this
is how you implement a state in a functional language.
Because, is this like the state monad?
Yes, exactly.
Oh man, I would love to learn what the state monad does or how to use it.
This is how the parser is implemented. If you remember,
I remember the first time when we wrote it on our own. Yeah,
it's a state to result in the state.
Yeah,
and I'm thinking just in these terms, how to maybe make this COM event in that sense, that I put a state inside. And because when we start a Roland program, we have already some kind of state. Mm-hmm. We have registry. We have what we have. Well, we have this
whatever process you're about to run.
Mm-hmm.
Yeah. But I think this is some kind of an environment that I will put inside, and I will just manipulate this environment as a state.
Yeah. That seems like a great idea, man. I think that's awesome, and like I would love to see how to do that. Because like when I watched that early tutorial learning how to implement a brainfuck interpreter in Haskell, they were using state monad there, and just every time you run an instruction, it basically gives you like the next state. But that's like it's such a simple example that I didn't feel like I fully understood like everything I could do with that monad.
Yeah.
But what is complication? This pattern of state monad, you're really simulating a co-monad, because you are generating things, not reducing. And because Haskell only have syntax for monad, like a do notation, and all of this stuff is all of these combinators are for monads, not for co-monads. So this is why this is like other way around. It would be much simpler with co-monad, but I don't know how to do it with co-monads.
Yeah.
But
I don't even know what a co-monad is. I barely know what a monad is.
The monad is a sequence, and you can collapse it because you have a join. You have list of list to list, and the co-monad is a duplication. So you have a list. You can duplicate it and make the list of lists. Mm. And I will send this link in Discord. It's very interesting how to this guy that made PureScript. He made implementation with the co-monad and monad implementation of UI. And
implementation of what?
For UI as a general framework, and he can explain all the different. All different implementations. So, for example, for React, for how it's called in PureScript, I'm not sure the UI framework. But you can have different models of UI definition or execution implemented at this time. So you have co-monad, monad inside the co-monad, and this is the pattern that they explaining in the deep and shallow embedding, because you have comonad that generates, like a parser that generates terms from the syntax, and you have a monad which do reductions and combining all these things. And
that's
I'm not sure
like
how
a
to implement
presentation you saw. A guy gave a presentation on that.
Yeah. I will definitely send the link for this.
Yeah, cool. Thank you.
I would like to implement exactly these things for rolling execution, if it's possible.
Oh, that sounds really cool. We're gonna learn so much. That sounds great.
Yeah, but it's also for me.
So
like
let me ask like a really Let me ask a really stupid question. So why do you want to keep the process or the continuation like around as a function? Why do you want it to be a function? Is it like for like type checking or what exactly?
Oh no, I want to have a state.
You want to have a state. Okay.
I want to have this state, but probably this function will not be enough. I will need some kind of more abstraction. But I really, my motivation is just to have this state from each COM event that I can supply it and return it back. And this state will be really the state of, this will be the tuple space in a sense, but.
Yeah, so is the function like the transition that happened from the first state to the resulting state? Okay.
Yeah, and in this function, I was thinking maybe I can put everything in this function and just just fold all over the tuple spaces, execute all the comments.
Yeah, right.
Oh wow, that's a super interesting idea. So how do you do with non-determinacy?
Well, if it is possible, I would like to execute the branches in parallel, just fold.
Oh, cool. Then it's like what Isaac had, where it's like these are all the final states. Is that what you're thinking? Like if you execute all the branches?
This is why I was asking Isaac how to implement this. Should I just execute everything in parallel and just don't care about anything, which I will definitely do. And that's it. Because I was thinking maybe
that sounds like a good first way to approach it.
Yeah. So after this session,
that's basically my idea. Like, I have an idea. Like, I'm just gonna do a bunch of stuff, and then maybe I'll look at some documents and see if what I'm doing actually has any bearing in reality, or if it's just fun.
But this must be simpler to just fold whatever I have and just don't care about, is it in the same level, or I can just reduce whatever I have and that's it. This should be like a little simpler. That's cool.
Yeah.
So thanks about that.
Oh yeah, absolutely. Well, should we call it for today?
Yeah. Oh, I wanted to just plug the Rolang wiki for just a second.
Oh yeah.
In case you guys.
I see. I'm sorry, I didn't.
Oh yeah, nice.
So I put together this shitty landing page. If you know a web designer or even an amateur, I would love to have their help.
Oh, that's a great image.
It's okay for a start page. I like it.
Have you met Rosie yet, Tomislav?
Yeah, I've seen it.
Oh yeah, Tomislav needs to meet Rosie.
Yeah, and I was thinking this is like a great idea, and maybe we can use your technique for like a more general, so you can
definitely for any sorted logic, you could definitely come up with a diagram quite like Rosie.
You said multi-sorted.
Any sort of logic, yeah. So like any programming language would fall in. Yeah.
I didn't hear you again. Sorry.
I think my connection is many sorted logic. So like you have different sorts, and these are basically like the they're essentially like types. It's like basically any programming language would fall into the paradigm of many sorted logic.
I see.
But I guess it's like a more general structure.
Okay.
Yeah. It's basically just capturing like the function symbols in the logic.
I have another example of one somewhere.
Oh, cool.
But where?
I started drawing some for the implementation I was doing in K framework just to try and understand it a little bit better, but I haven't drawn like a full one yet because there are just a lot of sorts that I'm dealing with.
Oh darn, dude! I had another one that we could have looked at, but I don't know where I put that. Not in Erlang, huh? Oh well.
Oh no.
Well, it's
that's all right. I think
this one. That was the one that I drew.
Oh yeah. Oh, that's right. Yeah.
For the simplified Erlang grammar.
Cool.
Right.
But okay.
Oh yeah. Joshi, I don't know if you were around at the time, but in terms of the structural types and the behavioral types that in terms of the structural types that I'm working with right now, everything is in terms of processes. Only process variable. Yeah, and then in the the implementation where I'm like actually trying to do stuff with like the tuple space and the behavioral types, those are all everything is in terms of, well, it's like names and processes, but there are only name variables in that one currently. So like I at first everything was just name variables, and then I was kind of building from there. Well, at first I tried to do both name and process variables, but I always have issues when I do that. So I just naively chose like name variables because it's easier to type out some terms if you have name variables. You don't have to constantly put like @x for a channel name.
Dude, you are it's exactly why I want to get rid of the distinction, because you always have to type @x and all that stuff. And look, while we were on this call, I was watching the dev thing here, and like people send code all the time, like this one, and then they match res. People hate those stars and ats, and they don't add any expressivity, man. I really think we should get rid of them.
Yeah.
But Isaac, you're not talking about this distinction.
What's that?
You're saying that you're using only one representation, but you have distinction. But you always using one representation.
Yeah, I mean, there's not really a real distinction though. I mean, it's like, okay, I made right, exactly. So yeah, there's a syntactic distinction. Like I can't quote a name, right? I can only quote a process basically, and I can't like evaluate a process.
So you are converting everything to only one representation, and this is like a.
I mean, I don't have like a full-fledged plan to like make everything all processes or names or anything like that. But definitely it's so K framework complains a lot when I try to inject identifiers into two different sorts, because everything needs a least sort, and it can't be that I have identifiers injected into names and also identifiers injected into processes. It just doesn't like that. It can't handle it. But that's because everything needs to have a unique least sort, and that immediately violates that principle.
Yeah, and you must have some.
Yeah, and so you like if people
memorize in every case, how is defined the syntax, and you must follow this to the whole calculation.
Yeah. Yeah, so I guess what I'm saying is I think I think I agree with Josh, and the distinction is unnecessary.
Yeah.
I don't know if eliminating the distinction adds or takes anything away. But now
You mean
at least you don't have to. Yeah, right. Like they're only processes. Yeah, so I mean, but like if you think about it, that's kind of what's happening anyways, is like you can think they're only processes, but when a process is in like has a certain like tag on it, like an @ then it can be put into certain contexts. Like it can be put into like a channel context, basically.
That's a good way to think of it.
I mean, that's kind of how I was thinking about it from the beginning, because like, you know, from the beginning, everything is created from processes. So really there is no distinction. It's just like a name is a process in a certain context, essentially.
Yeah. It's funny that it plays out differently in Rolang versus RoCalc too. And I think that's why I got stuck so much on the semantics of drop, where like, the process, I still don't totally know if I get it. Like when you drop something, you're not actually going to run that name that's in there. Only when you substitute something in, then you're going to actually run the thing.
Yeah, right.
And that doesn't exist in Rolang, and it's not necessary because we have these like variables, right? You're never substituting in for a previously concrete thing. You're always substituting in for a, you know, like an X or something.
Yeah. Well, so the difference would be like if in Rolang, if I were to type in a process like start at 1, like what does that actually mean? You know, like, I mean, it's just a ground process. It does nothing, just like the process 1, but it's not an integer anymore. However, if I were to put like,
but this is syntactically.
I mean, there's something interesting there. Yeah.
Sorry, what was that?
If you have a val and quote, this will be erased.
Well, right, exactly. So like, but that's only because Rolang treats them as inverse operators, right? Like in RoCalc, we write something like start at nil, like that is actually different from nil. However, when we do a substitution in a particular way, it turns into nil. So it's like it has to be nested in like as a continuation for that substitution to ever happen. So like it has to appear in a certain context for us to like remove the evaluate or drop or whatever and actually run the process.
And it wouldn't turn into nil either. It would turn into whatever you substituted in for nil. Right?
Yeah, that's right. Yeah.
Yeah, so like with Rolang, we're never substituting in for a nil. You're always substituting in for a like my variable or something, right? We're not replacing concrete things. We're replacing like X's and Y's where we specifically have holes.
Yeah, variables.
So we don't need those subtle semantics about like, you know, drop only means actually run this thing once we've done some substitution. And so I think that's why we can get rid of the distinction.
Okay. Yeah, that makes sense because now we have variables and instead of everything just being like concrete processes.
Yeah, right. Okay. Exactly. So like you needed in RoCalc, you needed a way to say, I don't actually mean send nil on nil. I just mean this is like, that's what I'm calling my variable. And whenever I sub something in for it, then go ahead and run it.
Right. Okay.
But in Rolang, we do that by saying new myvar, and then we just put myvar wherever we want.
Right. Yeah.
So you're saying that you want to get rid of a quote and the star.
Yeah, that's what I'm saying. Yeah.
Cool.
Yeah, and like you might as well, I guess, because basically anywhere they turn up. Well, so how? Okay, if you get rid of stars and quotes, then how do you know what you're allowed to, like, where do you send messages at that point? Like what are, so like we're using names as kind of like locations or something that we can actually put these processes to then be, whatever picked up by like another process. So how does that work in a Rolang that has no quotes and dequotes?
Yeah, you can do something like, so let me just type some example code and see if it
Sure.
it gives you a place to ask, like, how would something else work? So we could do just like, x bang nil.
Mm-hmm.
And then over here we can do like for, I mean, you've seen this a million times, I guess.
Mm-hmm.
And then like, okay, so what do we want to do in here? We could just do y.
Yeah.
So this is not valid co-op Erlang, but this would be valid like in what I'm proposing.
Oh yeah, sure. Because you're listening. Yeah, y is like a name pattern in that context, but then you're instantiating it as a process.
Right. So in co-op Erlang, I'd have to do this.
Right. Yeah.
Is this just only implicit, this conversion, or?
That's one way to think of it. The way I plan to implement it is not to ever even have a data type.
Mm-hmm.
The constructor for send is just parametric in two processes, the one you're sending on and the one that is the message.
Yeah. Well, okay. Here's potentially an issue with that. So like, okay, if I have, the process X running in parallel with X bang nil, so like X par X bang nil, and so I guess we just have to define the precedence properly then. So as long as the precedence of the send constructor is higher than the par constructor, then this is okay.
What are you thinking of? Oh, are you wondering like, is this sending on X par X?
Exactly.
Oh, yeah. That's a precedence thing. And sometimes it trips me out when you write your terms on one line. So used to putting them on two like this.
Oh yeah. I just condense everything to one line.
Yeah.
I mean, don't look at my K-framework code though, then, because it's like 400 characters long on one line. Like, I just don't care.
It's like more process calc, more like mathy way to write it, I think, right? Whereas this is the more like every line ends with a semicolon way to write it.
Yeah. Okay. Yeah. Right. This is like more of an imperative style or something. Yeah. I don't know, man. I'm just making it up as I go along.
Oh yeah, totally. Well, but all I was saying is it's just precedence.
Mm-hmm.
Oh, but
right.
Isaac, you're saying because we don't have code here, this is the problem.
Well, no, I was thinking maybe it would be a problem, and then I realized, well, actually, if we just do the precedence correctly, and we know that send binds tighter than par.
But we can have similar situation if this is not new but for, and if this x is a process variable, then.
Mm-hmm.
Yeah, and if in for you say at x.
There's no at.
But yeah, but now in Erlang you can say at
co-op Erlang. Yeah. So we could do that.
And you have exactly the same situation. You have x without quote. Right.
In co-op Erlang, this is not valid anymore because you can't send on a process.
Right.
You would need to put the at right here.
Yeah. I was thinking other way around, but yeah, you must put a star in the first case. Then.
Yeah, or in co-op Erlang, you would have to do this. Yeah.
Yeah.
I don't know why, and I can't really put my finger on it. This distinction between like, is it only names or is it only processes or is it both, is really reminiscent of the, is it monadic or is it polyadic or is it like maybe a little bit of both distinction. I don't know if there's anything to that, but I'm definitely getting that kind of sense here.
Yeah, some of the same.
Like, it could totally work either way. It's just yeah, right. Yeah, so it could totally work either way. It's just a matter of like preference, I guess. I don't know. Yeah. Maybe there are really good reasons to do one over the other, and I just can't see it yet.
Well, we're all exploring it, right? We'll find out.
Yeah, I'm wondering if this can be replaced with implicit conversion. If you know exactly the place where this is happening, so you can do this conversion implicitly. Because
Yeah,
I'm thinking that on the backend code, you need to know what is the name, what is the process, because you want to have types all the way down. You want to have all correct by construction.
Yeah.
But what you are saying, this is maybe not necessary on the syntactic level.
Oh, I thought I was saying something deeper. I'm certainly saying it's not necessary on the syntactic level. I thought I was also saying it's not necessary even like anywhere, even for CBC, but I don't have that, totally crystal clear picture of CBC, so I could be wrong about
that. I will try it. I will try it and see, because I'm thinking maybe you cannot type check this in implementation.
Yeah, that's a good thought. I haven't thought all the way through that. But about implicit conversion is definitely possible, because the co-ops interpreter even gives error messages like name variable X in process context on line whatever. It tells you exactly what you need to do, so it could do it implicitly.
Yeah, I mean, capturing those contexts shouldn't be difficult. And then, just like, I don't know. I mean, but that's basically what we're doing anyways, because really everything is processes, right? If nil is a ground process, everything has to be a process at that point, and then names are just kind of like decorated processes. But that's essentially what we're doing, is like when we put a quote in front of a process, we're just putting it in a name context.
In fact, the name process calculus is a lot like the red-black calculus, right?
Yeah.
The name ones are the red-black. Yeah, we just tagged.
Well, yes and no. I mean, okay. The way that I am implementing it in K-framework, it's very much like the red-black calculus, because I found it made more sense for me to instead of having unforgeable integers as processes, I made them names. So like I have things that are already names, and they're the unforgeable integers. And then I also have the processes like nil, and then, all of the built-in stuff as well. And then the interactions between the two.
Yeah.
But yeah, I don't think I think you can do everything with processes, basically, is what I'm saying. And I think we're basically already doing that, and we're just convincing ourselves that we're actually doing something different. So like, my understanding was that the reason we had the quote operator was so that we could somehow like package up the code of a process and like, send that as a message or something, but I'm not even sure what that means 100%.
Yeah, right.
It's a way of saying like when we do a COM event. Sorry, I don't know if my connection's breaking up here.
Yeah, you want to say something?
Yeah. So I was just wondering if that packaging the code of a process up, if that's just a fancy way of saying when we have a COM event, it's the quoted process that's actually substituted. I mean, is that really all that we're doing there? Like, I mean, I guess I'm just asking what it means by like packaging the code up.
I mean, so in one way, I didn't interpret that to be like a super formal thing. If you think about like a program that is actually running on hardware and you want to move it to other hardware, like you can't move it while it's running, right? You have to copy state and stuff. I always kind of just took it to mean like,
right,
to kind of take that analogy and say like, look, that problem's solved over here, right? There's no problem about moving where this thing's running, even as it's like, a process.
Yeah. Right. Okay.
But yeah.
Well, I mean, it almost seems like choosing one and sticking with it is better then, because you don't have to start from the assumption of the distinction there and like, oh, there's like the code and then they're actually, executing the code. It's just like everything is executable code, and we're just going to start there.
Yeah, well, that was the other part of the thought. Like maybe we got in this situation just because like we grew out of the pi calculus, right? Pi calculus says, here's a bunch of processes, and by the way, you need names. And so, Greg's insight is like, wait, what if the names are the processes? And, then the next step is just like, well, yeah, what if they like literally are the processes? Like, what if there's not even two separate different things?
Yeah. Yeah, and I guess what I'm saying is I think that's already the case, and we're just not calling it that.
Yeah, totally. Yeah. Me too.
Yeah.
Josh, I want to ask you about this wiki page.
Oh yeah, sure.
How do you imagine how do
What
you
does it look like? What's the vision?
Yeah.
Well, my vision isn't very specific in terms of like content. Like basically anything Rolang related is welcome here, and I'd love it if you throw in anything you want. Probably not like co-op drama. That I don't really want that to end up in there. But yeah, just like a place for people to gather that like Rolang and want to share stuff they know. Because the docs have traditionally been pretty shitty, and so maybe we can change that.
Yeah, this is cool.
Yeah. My hope is that the most of the content will live here in the wiki. But then there's also like, this thing sucks so much. But I was hoping this would go to my tutorial, like looking nice at some point, and then try nice. Rolang is
Rolang Cloud, right?
Oh, or maybe
Archain Cloud.
Yeah, the link is broken apparently, but it's the Archain.cloud software.
Yeah.
I think it's because it can't be HTTPS. I kind of want to just fix that, but like.
Oh yeah.
And then I'm hoping also eventually I can get a visual like block-based programmer in here, but I just have been having a hard time being motivated to work on stuff lately. So maybe when spring comes.
What do you need? Block.
Oh, okay. So let me just show you something similar. Have you ever seen this?
Oh yeah, this is cool.
So I used this when I was a high school teacher. I used this when I had freshmen who had never programmed before. And I'll skip the tutorial and I'll just give you one. So basically, this is Scratchcat. And
I tried.
Oh, you've seen it. Great.
Yeah.
Oh yeah. So basically I want to do the same thing with a Rolang language. So instead of like a loop, maybe this is what a par looks like. And then you can drag a block in here that's like, this would say, this is a send, and it's like, well, send would need a continue. No, this is a send. Oh no, sorry, it needs a continuation. So like send might look kind of like this. So I type in like what channel I want to send on, X, and then in here is the process that I'm sending. And then, that's paired in with another send, and that's paired in with a receive or whatever, something like that.
Yeah. Yeah, and you said that you can design your own little blocks in the Scratch thing, right?
Yeah, so basically that's right. Not specifically with Scratch, but there's this thing Blockly, which is an open source thing mostly by.
Oh yeah, okay.
So I did design my own blocks at one point, but I failed to save them correctly. But that's okay because I was just playing around and I could do better again anyway. But this is what I used to design them. It's a little Inception-y right off the bat because they actually have this like Blockly interface to make your own Blockly blocks.
Yeah.
Oh, recursion.
Yeah, exactly. It's like
reflection.
Yeah, reflection. Yeah, that's right. I forget exactly how it works, but if we play around a little bit, we'll probably be able to figure it out. Oh,
but there is also normal API, right, that you can use. And
yeah, you can also write this. Like this is what it's generating.
Oh, they have some intermediate languages. Oh, this is JSON.
Oh, it's just what we're writing right now is just the syntax. So like we're basically writing the parser kind of, whatever shape these blocks end up having is whatever syntax you can put in. And then the syntax is basically just serialized down to this JSON format, or I think they have XML. I guess they have some other thing.
Oh, I see.
So is JSON all records?
JSON is records. Well, they call them objects, but yeah, they're basically records. List. Here's a list, and then your basic like string, integer, Boolean. That might be it.
Yeah, I've only seen JSON like a couple times. When Glenn was presenting that stuff, that was pretty cool.
Yeah. So, I mean, Isaac, you've seen XML more with K-framework, but this does everything that XML does, basically.
Mm-hmm.
And what do you think for start? What will be enough? I'm just thinking for
In here?
For like for this app.
Yeah, like what would be the minimum? My sort of like first milestone was going to be blocks to represent the asynchronous pi calculus and generating Rolang code that can be interpreted with the co-ops Rolang interpreter.
This is cool.
Mm-hmm.
So
because you want directly call, make a blocks, create like some kind of block of process from blocks, and then you want to just send the code to Rolang.
That's right. Like the classic example of using this is that they just have a Blockly. In fact, I bet I can find this. They have a Blockly interface over JavaScript. Here it is.
I see.
So, that's cool. I didn't realize it was going to do that. But so this basically just looks like JavaScript code, right? Like we've got all our regular, or not all of them apparently. I thought there was more than this, but that's what it does on it. And then it just like literally generates JS code. Like I could give that to Node or something, you know?
Yeah.
Or up there apparently.
I see.
Yeah.
So if I could just get it to output Rolang code, like I feel like that's a pretty big win. That's a good way to say like, hey noob, play with these blocks, and you automatically get the code you wish you could have written or something like that.
Yeah. Well, and like your whole idea was, the whole reason you started doing this was kind of because like Rolang is pretty confusing, especially to like teach somebody who doesn't know any Rolang. It's pretty confusing, and you're like sending these messages, and it's like a totally different paradigm. But with like these blocks, you can kind of like abstract away some of that syntax and just like focus in on like what are you trying to like build here, and then just kind of like put the pieces together instead of worrying about like, do I need to star or at this thing? And
or like I noticed that people who are learning to program struggle a lot with things like, do my quotation marks match and do my parentheses match, and you know.
Right.
Oh yeah.
Right. Yeah, and then you just don't need to worry about that crap.
Yeah. So we'll see. In fact, hearing that you guys also think it's a good idea might be the motivation I needed. So we'll see. Maybe week.
I think it's a good idea. And honestly, it doesn't seem like it would be all that much work to like get it to the point you would want. I mean, I have no idea how much it takes to like take one of these blocks and actually generate the code from it, but it seems like it should be fairly straightforward with the interface that they have.
I also have no idea, but I think it's not that bad, because like, look, this is what they're calling a generator stub. And it's basically just JavaScript code, and the to-do they have for me here is like just to put together whatever string I need. Like at the end, this code variable should be some string of Rolang.
Yeah, right.
I assume that like, you know, most of my blocks will be parametric and other things. I assume there's some way that I'm able to access like the children that constructed this.
Right.
Yeah.
Yeah, like the allowable inputs or whatever.
Yeah. So hopefully it won't be that bad. Oh, but then, you know, so that was the first goal, right? To generate co-op Rolang code. And then my next, this is partly why I started doing the Rolang thing in JavaScript too, because it would be cool if we could write an evaluator for this thing. And if it runs right there in the browser, that would be a step closer.
Yeah, that would be great.
Yeah, but you know, additionally, then I am a better JS programmer than a Haskell programmer.
So the first step is really just to use this as another parser.
Totally.
And
Yeah.
Okay, that makes sense. Yeah.
Yeah, or it almost feels like a transpiler almost. Like we transpiled it from this block-based async pi into this text-based Rolang or something.
Yeah. Exactly.
Yeah. So. All right. Well.
Okay,
I don't think I have anything else to share.
Oh, I just want to plant this seed in your brain for when you're developing that stuff. If there was a way to go from text Roland code to the blocks, that would be freaking cool.
Yeah, that would be cool. Totally. That is a later goal, but I think that would be, because what would really be nice is if you could do them side by side, as you drag them around, you see your real-time Roland code, and then as you start to learn it, you're like, well, it would probably be easier to type this. I think one thing that's hard there is that with the blocks, you're guaranteed to have a valid AST that definitely has a representation in text. With text, if you have a syntax error, it won't go to blocks, which is fine, right? That's just a parse error. That's you know how to do that. Yeah, that is a good idea. Maybe that's an achievable goal.
I mean, that's always what I'm thinking is like, how can I turn the code on this page like into a picture for people to look at and understand, and then I can just explain the picture, and then if people have further questions, then I can show them the code, or examples and then the code or something.
Oh, and I'm gonna show that one more time. The Scratch one, oh no, my Zoom tools are in the way. There we go. So if we do it like this, where like this forever loop represents par, and then I have like send, receive. One thing that's unfortunate about writing Roland down in text is that you do have to write these things in some order, even though they're parred and the order doesn't matter. Like they physically are presented that way. So what I would love, like Scratch is cool because at this root level, I can put as many of these things over here as I want, and then somehow, like these, you can give them different events to start on, and then they actually do run concurrently with each other. So what would be cool is like if this par one, instead of looking like it does in an imperative language, like in Scratch, this is exactly the right way to do it because order doesn't matter.
Right.
But if this could just be like a big box, like an area, and then inside that area, I could put all of my like send and receive, so that it's clear that if I scooch this one up here, nothing changes, and if I scooch this one over here, nothing changes. Then people won't get confused about like what order this stuff has to go in.
Right. Yeah. It's literally just like a bag.
Yeah. But that's a
Hmm.
lot harder thing to code because that gets into like graphics libraries and making this thing look not like this, and I don't know how to do that.
Yeah, I would say if you get the first implementation working, then maybe that's something you can consider afterwards.
Yeah, totally.
Yeah, that's pretty cool though.
Yeah, thanks. All right. Well, I think I'm ready to wrap it if you guys are.
Yeah.
Good hanging again, as always.
Oh, great.
Yeah. Thanks, guys.
Yeah.
Always like showing you guys my code because I always think about it differently afterwards. It's really helpful to try and explain it to someone else that's not the person that's been looking at it for like 50 hours this week.
Yeah, totally. I always think it's funny too that at the end of these calls it's dark in Croatia, and I can change the color of Tomislav's face by showing a screen that's mostly white. It gets darker when it's mostly black.
Oh,
that's funny.
I have when we start, I have like only one light, very small. So
yeah.
All right.
That's funny.
All right, Jim, if you're still sitting there, thanks again for hosting, man, as always.
Yeah. Thanks, Jim.
See you.
All right. See you guys later.
Bye-bye.
All right.
Bye.
See you later, Tomislav.
Oh, see you, Isaac. Bye-bye.
Bye.